part of a metaphysical story that goes along with physics but doesn't have to go there. I mean, we can think of the statistical mechanics, whatever theory of physics we want, without it. Certain reviewer wrote to me some time ago that he rejects my claims on this point. I mean, I'm not going to the statistics. My argument is that the fact that there's a point in probability space doesn't mean that there's a corresponding physical state. So not everything that is in the math of a theory corresponds to possible reality. It's a matter of interpretation. What chunks of the math we take as representing reality. And this is not something we can escape. Anybody who looks at a theory of physics has to interpret it. And once you have a probability space, it's on you to decide what in that space represents reality. I'm not saying it's an easy task, but it's not a priori that every point. So if there's a point in probability space where, a coin can fall 100 times on the same side, that doesn't mean that can actually happen in reality. And it's not obvious to me that physics needs to tell us that it can't happen, or that physics tells us that it can. So a reviewer just wrote to me a couple of days ago, and he doesn't understand my point on this because there is no conflict between physics and experience. Physics gives us the option of a coin falling 100 times on the same side as a prediction, and experience tells us we're never going to witness it. So where's the problem? So I don't exactly understand. The problem is there's no reason to think that this is an actual possibility that now needs to be accounted for. And to say it is a possibility because physics says that it is, but it's not a possibility because we know it's not going to happen seems to me a very strange kind of response. Okay, so where are we? So I think humanism has a few advantages, but as we all know, for the past 100 years it's been positivism, the black universe, eternalism, not positivism as a philosophical school, but the offshoots of positivism that has been dominant. So it's been positivism and not humanism is the dominant approach in the metaphysics of time among philosophers and scientists, and I'm just repeating again, you've heard this already today. The reprimands of Einstein-Bergson, it's like a school teacher setting one of his students straight. But they've been absorbed quite deeply into our culture. And the bifurcation of time into psychological time and physical time, psychological and cosmological time stands. And a lot of the debates and the controversies in the philosophy of time spring from the notion that there are these two times and somehow we need to figure out what the relationship between them is and what we should learn from each about the other and so on. But as I said before, there's one time can be described, studied, contemplated from many perspectives, but it's always that same thing. Not object. I don't want to objectivize time, but it's always that same thing that is being contemplated. Just in parentheses, I'll make a little advertisement for a book that was mentioned before. The book in which there's an attempt, it's a collection of papers to rethink about this rift between cosmological and psychological time. It's still available. Constitutes my whiskey fund, so you're welcome to contribute. Okay, and that brings me to my next to last point. So I have two more. One is that the arguments that have been mentioned here are philosophical and not scientific. And as Bergson said in that exchange, that 1922 exchange, a metaphysics grafted upon science is not science. And I think that's a very important remark to remember, because I think it's happening now way more than it did 100 years ago. The scientists put forth philosophical theses, but present them, certainly to many audiences, as either actually scientific or at least corroborated by science. And often that's not the case. Okay, so anybody is entitled to any view, and everybody can present whatever they want. But you have to say what it is that you're presenting, and it's not clear that Einstein himself did it in that exchange. I think this is a very accurate complaint that Bergson registered. That what Einstein was presenting was a philosophical stance, probably inspired by his theory, but not established as truth by that theory. So the dispute between them was not a dispute between science and philosophy. It wasn't even a dispute between a physicist and a philosopher. It was a dispute between a philosopher and a physicist doing philosophy. And I think that's the light in which this dispute has to be seen. Which brings me, before that, Putnam was mentioned, so I want to go back. I think it was Jimena that put up the quotation from Putnam. And I think, and I say this, my friends here know, with infinite admiration for the man, on this point he was wrong. He was dead wrong. So I'll just read to you what Putnam said, and this is the conclusion of his 1967 paper on geometry and physical time. This is the quotation: "I conclude that the problem of the reality and the determinateness of future events is now solved. Moreover, it is solved by physics and not by philosophy. Indeed, I do not believe that there are any longer any philosophical problems about time. Physics has settled them. There is only the physical problem of determining the exact physical geometry of the four-dimensional continuum that we inhabit." So physics has put an end to 2,500 years of debate, starting with Parmenides and Heraclitus, about the nature of time. And all that is left to do is to do more physics. And just listen to how positivistic this statement is. It's got to be stated, yes, that this, again, was written in 1967, and Putnam gave up on this position many times and completely in later years. So my last point. At its origins, positivism started out, among other things, as a political movement. I don't know how much this is mentioned when positivism is taught in philosophy classes, but it had a very substantial political agenda, and this political agenda was a prime motivator for the members of the Vienna Circle, who took it upon themselves to try and understand why the mother of all wars, the First World War, occurred. This was a war that came after an era of great optimism, certainly in science, huge achievements of the 19th century, and broke out for reasons that nobody really could analyze in sufficient depth back then, and as far as I can tell from what I hear from historians, even now. And the agenda of the positivist was to develop what they called the scientific world conception. And not merely as a philosophical stance, but as a platform for political action aimed at no less than saving the world. So this is a quotation from the same chapter I read to you from before, from Otto Neurath. So the Vienna Circle endeavors toward a new organization of economic and social relations, the unification of mankind, towards a reform of school and education, all show an inner link with the scientific world conception. It appears that these endeavors are welcomed and regarded with sympathy by the members of the Circle, the Vienna Circle, some of whom indeed actively further them. We have to fashion intellectual tools for everyday life, for the daily life of the scholar, but also for the daily life of all those who in some way join in working at the conscious reshaping of life. Now, as I mentioned, as a philosophical school, positivism no longer exists, but some of its offshoots do. I've mentioned them, and some have taken a disturbing turn. So there's a metaphysical materialism that is very popular now, a certain kind of naturalism, which is very widespread. And again, the basic tenet there is the notion that it's all physics, or it's at least all science, and that if it's not in the physics, it's not in the world. And this is anti-humanistic in the philosophical sense of humanism, James's sense, but also in the, I'll call it, ethical sense of humanism, And I have in mind a reductive eliminativism of morality, of normativity in general, that sees all of these as a kind of noise that accompanies the interactions of particles. I was looking, couldn't find, but there was a review that came out in 2014 of 3 books put out by philosophers. I remember one of them was at the time the chair of the philosophy department at Chapel Hill. All of them denying the reality of normativity in general, of morality in particular, and all of them claiming it's not in the world of nature, and therefore it isn't. And that has its dangers. Nowadays, we constantly run into scientists claiming that it's all in the brain. The good and bad, the ugly and the beautiful, the odd and the is, it's all there. And that's, of course, a variation on that theme, which I find disturbing. But again, originally, positivism was humanism, not in the Jamesian sense, but in the ethical sense. The Vienna Circle scientific conception of the world was developed as part of an attempt to, as they said, reshape Europe and indeed civilization. So last quotation, we witness the spirit of the scientific world conception penetrating in growing measure the forms of personal and public life, in education, upbringing, architecture, and the shaping of economic and social life according to rational principles. The scientific world conception serves life, and life receives it. This is a political manifesto. And at the end of it, there's a list of the members of the Vienna Circle and those sympathetic, but also of leading representatives of the scientific world conception. It's Einstein, Russell, and Wittgenstein, who was not happy to be included in this, under this label. And indeed, Einstein and Bergson were both, they were both great humanists in the moral sense of the world. And in this sense, I think they shared a lot. The well-being of human beings, according to them, must come first, and it does not depend on how human beings are conceptualized philosophically or studied scientifically. And when we know that when it came to the lives of people, both Einstein and Bergson stood out as glaring and unshakable lighthouses of humanism and of morality, and they both lived through very, very challenging times in this regard. You know the story of Bergson, yes, but he converted to Catholicism. But when the Nazis required all the Jews in Paris to register, he insisted on being registered as a Jew. And both of them took their solidarity with the plight of the victims of the Second World War to be of major significance to their self-conception and to their mission in the world, probably before being a physicist and before being a philosopher. And they really stood out as beacons when calamity struck. So in this sense, I think they were a very good choice for as subjects for a conference marking 10 years of recovery and rebirth from calamity. Thanks.
Thank you, Yuval. And I think that we have time for a couple of questions.
Oh yeah?
Alessandra?
Yes.
A couple? Okay.
Maybe
After
3 or... Depends, we are until 3:30.
Okay, cool. Okay, Elvira?
I can also speak loud. Okay, even louder. So thanks a lot. That was very interesting, and I'm sympathetic somehow to the humanist view. But nevertheless, I have a basic question about how exactly they differ from each other, starting from the way in which you portrayed the difference between them. Because it seems to me that they work on different levels. It seems that the Neurath quotation has to do with epistemology, like the way in which the sense impressions, so saying that the sense impressions are a source for knowledge seems to me like an epistemological thesis. While the humanist, the way in which you described the humanist thesis seemed to be more a metaphysical thesis, because you said that according to this view, sense impressions and also other stuff, things, objects and colors and sounds probably, they all constitute reality. So I wanted to know more about in which sense they actually differ, because in the end they can maybe agree in a sense. Just because you presented them as working on two different levels.
Yeah, no, I don't think that either can be labeled as just epistemology or just metaphysics. And I think in this context, it's hard to draw a line between epistemology and metaphysics. Certainly for the positivists, the epistemology that limits itself to sense impressions was the basis for metaphysics. The scientific world conception is a metaphysical stance about what reality is. And as I said in the end, it was very important for them to develop this metaphysical conception of reality because they thought that's where the key for the prevention of the next catastrophe in Europe lies, a sound understanding of reality itself, a metaphysical conception based on the principles of science and so on. And likewise, for the humanists, you're right, it's, the various sources of input are part of what make up a metaphysical understanding of reality, but you know, that's their epistemology. For James, how adopting an optimism that goes along with the notion that there's an absolute out there and that people are free to make choices for which they then bear moral responsibility and so on. That was his epistemology. It wasn't just his, you want to understand, if epistemology is the domain in philosophy in which you try to figure out how we come to have a conception of reality, then that was his epistemology.
Yeah, it's on. No, it's not. Now it's on. Thanks, Yuval, for your wonderful talk. I really share the feeling that you expressed in your last slide. And by the way, I also think that one has to look at this dispute between presentism and eternalism from an affective point of view, from an emotional point of view. But I feel that you mistrust science. You're optimistic about will, but you're pessimistic about science. Scientific realism is a sort of optimism. But it seems to me that you don't give enough emphasis to the fact that science explains why the sky is blue. It explains what pressure is. You're bombarding the walls of a bottle with little spheres. So it explains a lot, while you seem to be quite dismissive about the explanatory power of science. Yeah. And we can have science and humanism together, it seems to me.
Yeah, no, thanks a lot for this remark. I am so intent on a certain agenda that it perverses a little bit the presentation. No, I'm extremely admirative of science, of scientists, of the achievements of science. I would like to know a lot more about, the explanations that science gives for various phenomena. And no, I don't think I underestimate the importance and the contribution and the ingenuity that science. I didn't mention these. I should have. And thanks for your remark. And I completely agree that science and humanism go along very well. I think better than science and positivism. That was my point. My point is positivism and humanism are platforms from which we interpret scientific theories. And better choose the one over the other, not because it belittles science at all. To the contrary, I think it provides better interpretations of what science gives us. What I object to is presenting positivism as a form of science or as a framework preferred by science. It's preferred by certain scientists and by quite a few philosophers, but certainly not by science. Science has no preference. And I would advocate moving the weight a bit towards humanism.
Thank you very much. I've been very puzzled by the way you sort of draw the battle lines to continue with the martial images that we've been using here, because I see the basic problem or debate or opponents a little bit differently from you. And in particular, you seem to have put together two positions which I think are uneasy bedfellows as your opponent, and that is maybe to use labels positivism and eternalism. You seem to think that this is your opponent, when I think these are very, very different philosophical positions. The positivists were sometimes violently anti-realist, as was their big idol Ernst Mach, about the world out there, and they would never have subscribed to some sort of reality of the block, of the four-dimensional, space-time block, or anything like that at all. What's primary and what they're realists about, in a sense, are the sense data, and the project was to reconstruct everything from that. Whereas for an eternalist, that's a form of scientific realism, maybe about space-time physics, where you think that this is what we ought to be realists about, because it's been established by fundamental physics that this is something we should be committed to. So I think these two positions really are not the same at all, and I'm not sure, because some of your arguments then seem to be arguments against one or the other, but not against both.
Yeah, you're right that in this talk I lumped, probably a bit oversimplistically, positivism and eternalism, the block universe view. I did, one thing that I should clarify, I take humanism to be the right way to defend realism. So I was not trying, if I gave the impression that the positivists are realists or something like that, I did not want to give that impression at all. I take Bergson to be, certainly James, I think probably the best articulation and defense of realism over the last 100 years is James's, or students of James, such as Putnam and so on. So that may be a misunderstanding, but I do lump them together. Maybe I need to think about this more carefully. I don't know. Maybe I'm misrepresenting certain views. I think, with respect to the last 30 years, and there's maybe some bit of anachronism here, but over the last 30 years, the defenders of the block universe do tend to have been students of philosophical methodologies and approaches that I think have their origins in positivism, including, even though we know, he was his greatest adversary in a way, including people like Quine and Lewis, at least in the English-speaking world. I think most defenses of the block universe or the B theory and so on, that's the philosophical quarter they grow in, I think. But I probably should look at this more.
Okay, actually we have still a lot of questions, at least 4. So we have 2 questions over there. Yeah.
Mine was really only a comment. I'd like to just take a little bit further. That business about science is about providing explanations. And I go right back. I think the Greeks got it right straight off. They said it's about saving the appearances or explaining the phenomena. And then I would just add to that, Popper, that you make a hypothesis and explore the consequences of it and see if they're confirmed. But I would say science at its best is always highly provisional, that you just wait. There may be huge surprises. I've just been reading a wonderful book, Lord Kelvin and the Age of the Earth. He just could not comprehend that there were more forces than the ones he knew at the time. So he came to the conclusion that the Earth was at the most 100 million years old, and the Sun not more than 20, if you believe it, because he just could not conceive there were any other forces that could come into play. So I think science at its best remains open, and it remains open about possibly really wonderful things about whether hope is some fundamental part of the world. I personally think that we may yet still be only on the threshold of really great discoveries about what might come. I think it's completely open to me, as far as I'm concerned.
So, yeah, one last question, yeah.
Thank you. Not sure we can. So I really don't like to talk in the microphone. Can I just talk? Can I just ask you a question?
Yeah, I hear you. I don't see you, but I can hear you.
Thank you. I have a question about the point that you made about, with reference to Ellie Turing's talk. You said that, well, might not be an object, but it's something, right? And say that you can separate humanism and positivism in the way that you did. There's still a sense in which that there's sort of something there to which these two explanations or theories or ways of looking at the world are ascribing incompatible properties to it. So one of them, the experienced one, says that there's tense, there's something like a global now, just because we don't travel at the speed of light, and the other says that there are no such things. So it seems to me that there is clearly a conflict, and I think it's not just that there's a conflict, but that's a conflict that arises in everyday experience, but in some experiences that are accessible to us. So for instance, with the example with the ice and the water, obviously the statistical probability of the water turning back into ice is tiny. But when you think about something like winning the lottery, right? So it's my immediate experience of winning the lottery, and that seems to be in conflict with something that is also immediately accessible to me, and that's the fact that the probability of me winning this lottery is very low. And on this picture, this sort of science-y, positivist view can't explain why this is happening, whereas the humanist one cannot. And I think in particular in the case of time, I think that's why time is so peculiar, unlike space, for example. It's because in this instance, the two do come apart, and they are in conflict. And I'm not entirely sure how would you explain that when you're sort of slight, or it's not slight, preference for humanism.
Yeah.
So
That's a pretty pretty big question. Not to put Ellie's presentation into a nutshell by any means, but I completely agree with him that thinking of time as an object that now we study is not a good first step into the inquiry. So in this respect, I completely share with Ellie his sentiment. Don't think of it as as a bug that you're now going to put under a microscope and dissect. That's not how to approach it. But you made a few other remarks within this one question. I'm not entirely clear about how they all connect. Look, it's I think a very profound question in philosophy. What is philosophy? What are we doing? Why are we doing it? How are we doing it? And what are the tools with which we do it? Obviously, there are no empirical, positivism, humanism is not a question in science. We're not going to do some experiment. It's not as though you can have, a critical experiment of the kind that, both, as you say, offer explanations. Why some of us have, more taste for one type of explanation and others for a different, I don't know, but that's what we do. We argue. I think there are quite a few theses that come out of positivism, which I think can be shown to be incoherent. At the same time, I can't now think of one instance in which someone presented an incoherence argument to an opponent and the opponent was persuaded. It doesn't work that way. It's a little bit more like in politics. You may have very sound arguments. They're not necessarily going to be effective. So how you decide between positivism and humanism, I don't know. I think if you take seriously, and that's the only thing that I can make a plea for. If you take seriously your experiences, if you take seriously your obligations, if you take seriously a rich conception of reality, which includes, in addition to the things that you get from science, the moral sphere, the political sphere, all of these, humanism seems to be to cohere better with all of that and to enable you to see things more clearly and more profoundly than does positivism, which throws at your face a conception of reality that really is in great conflict with all of these things. It's not a decisive argument, it's not an experiment in a laboratory, but I think it has its power. And the case of the ice, of the water turning into ice, I think is a good instance in which to examine this thing, because it is so easily taken for granted by people that this is really just a question about statistics. But statistics, certainly statistics in the context of physics, not statistics as a mathematical theory, statistics in the context of physics is something that we need to assess on the basis of very many things that are given to us from our lives in this world. It's not a priori that just because, you know, from the viewpoint of a physical theory, this could happen, that it could happen. You know, I don't remember. Perhaps physics does not ban the possibility of time travel. Maybe it doesn't. You know, the Gödel loops were mentioned in the previous talk. It doesn't mean that we can make sense of this idea. I'm not saying we can't, but there's a question to be asked here. So with respect to what you do with statistics, as you meet them in the context of physics, all I'm saying is there's a question to be asked, and I have a preference for a certain side in this debate, due to what I take to be a much tighter harmony with everything we know from living in this world.
Okay, the very last two questions, very, very short.
No, but it's connected to the ice. So we connect
The ice.
the ice. I like the ice cube.
I can hear it.
Okay,
The ice cube in the glass of water. If I offer you a ticket of a lottery, it's for free, and but we have sold. I mean, the prize is $1 billion, but we have sold 10 billion tickets. So your probability is very low to win. Do you take it or not?
Of course I take it.
Yeah, because you consider this low probability, could happen.
Sure.
It's the same for the ice. There is no difference.
Disagree. I disagree vehemently, but we don't have the time to argue about this. I think that's a very bad analogy.
No, absolutely.
And I would take the ticket.
Identical.
Now you should give it to me.
Yeah.
I'll even pay a little bit for it.
Winning. You've seen people winning. You never seen a glass.
Because you
That's the reason why.
You have
Is that because you didn't
billion
wait long
times
enough?
the time of the universe.
You didn't wait long enough. Yeah.
Exactly.
But I want to, if you're already introducing bets, let's bet about coin flip. Because according to you, there's a certain probability of the coin falling. You know, there was a Scientific American popular paper in which a mathematician calculated the probability of a coin falling heads 76 times. I think that's from the absurd play, the Rosenkranz and Gildertin. And anyway, she concludes after a mathematical analysis of how many people, zero probability that anybody ever saw or will see a coin falling heads 76 times. Now you say, look, it's possible.
Number of attempts.
And I'm saying the question is more complex than just, you know, looking at probability space.
No, it's the same. Absolutely the same.
Right.
So, quick observation. It's not even a question, but I sympathize with the general orientation of your talk, of course. But I think you tend to downplay the philosophical impact of science on certain philosophers, like Whitehead, for example. You skipped over the fact that Whitehead really accommodated special relativity theory to the point of reforming his entire metaphysics to adjust to the basic idea that right now, if by now you mean the instantaneous now, what's happening at this present instant, if this is indeterminate, as you know, Einstein claims, ontologically indeterminate, then you should get rid of instants altogether. And that's the kind of metaphysical impact of the theory for Whitehead, is that there's no such things as instants anyway. So you're going to work with a thick presence, which brings us back to the first part of your talk about the fact that change or motion, actual process, is in itself indivisible or quantic, right. Quantum-like in the sense that it comes in drops as time itself. That's James' way of putting it. Time comes in drops.
Yeah, no, I think that joins Mauro's critical comment. I should, science can have huge impact. It does have huge impact on how we conceive reality and to some extent on philosophy. I think the mission nowadays is to stop the exaggeration. I think there's too much weight given to the impact of science on philosophy. So my agenda is in the other direction. Let's you know, regain some proportion. But of course it has.
But Yuval, there are flat earths.
I know. Not my fault.
I-
Maybe they're right.
I think the show must go on, yeah. Okay, then let's thank you all again. Okay, so it's my pleasure to introduce you Matthew Segal. Matthew is a philosopher, he's an assistant professor at the California Institute of Integral Studies. He received his doctorate degree in 2016 from the Philosophy, Cosmology and Consciousness program at the CIIS. His dissertation was titled Cosmotheanthropic Imagination in the Post-Kantian Process Philosophy of Schelling and Whitehead. He's also author of several books, and he also teaches courses on German idealism and process philosophy for the Philosophy, Cosmology and Consciousness program at the CIIS. So
Thank
I
you,
give the
Donna.
floor to Matthew.
So on the one hand, very good timing that I went after Yuval, because I'm not going to talk about Whitehead. On the other hand, I think we're 20 plus minutes over time, so I think I'll go a little bit longer than I was supposed to, right? Okay. 40 minutes? Yes, okay. So, you know, Yuval introduced William James into this conference, who was, of course, an important influence on Bergson and vice versa. James was also an important influence on Whitehead, and in a way, I think what Whitehead did is cosmologize many of James's psychological insights. If James was a humanist who centered human experience and made science one of the modes of human experience, I think Whitehead is, in a sense, taking cues from James, trying to defend human experience from greedy reductionism on the part of scientists. But on the other hand, Whitehead has a foot, or maybe a limb, because you need more than two, in four worlds. He is a mathematician. He was one of the few, I think one of the 12 that Eddington was mentioning, who understood Einstein when his theories were first published. He's a philosopher and also a human being who loved his wife and his children. He was very much a lover of poetry and so on. So very broad expanse of roles and modes of thought that Whitehead incorporates. And so I got very excited when I was invited to this conference, and I ended up writing a 10,000-word paper. I can't share all of it with you, but I'm going to skip the part introducing the Bergson-Einstein debate. Everyone knows what happened, what the stakes were. And I'm going to go ahead and share the section on what Whitehead might have said if he were present when Bergson and Einstein had this intellectual conflict. So, like all modern scientists since Galileo, rather than situating scientific theory within human experience as one of the latter's modes of relation to cosmic reality, Einstein opposed his theoretical model of space-time to our experience of being alive. So the existence of humans or any life form is thus deemed irrelevant to our understanding of the universe, time in particular. Bergson was not the only 20th century philosopher to protest against this sort of greedy reductionism. In Germany, through a sort of recharged Kantian transcendentalism, Husserl and Heidegger's phenomenological inquiries undermined the epistemological and existential grounds of scientific materialism. But the anti-naturalistic attitude of especially Heidegger leaves us with a rather intensely anthropocentric way of understanding reality, where all non-humans are considered poor or entirely lacking in world, as Heidegger put it. In England, Whitehead articulated an alternative philosophy of nature, which was neither transcendentalist nor naively realist. He attempted to avoid the false decision between transcendental idealism and reductionistic materialism by diagnosing and healing the metaphysical incoherence that he called the bifurcation of nature. While he would eventually leave his home country and travel to Harvard to take up the philosophical task of constructing a fully fledged metaphysical cosmology, it was Einstein's relativity theory that first drew Whitehead out of his early work on the foundations of mathematics and into the philosophy of nature. While Whitehead praised Einstein for the relativistic paradigm shift that he played a major role in initiating, he did not accept Einstein's identification of a curved geometrical manifold with the physics of gravitation. Like Bergson, he did not accept the implicitly metaphysical interpretation that Einstein attached to his theory. So in Whitehead's 1919 book, An Inquiry Concerning the Principles of Natural Knowledge, Whitehead begins to reimagine the scientific conception of nature in process-relational rather than materialistic terms. He argues that we must give up the attempt to, quote, conceive of events as in a given time, in a given space, and consisting of changes in given persistent material. Instead, we must come to see time, space, and material as adjuncts of events, he says. I quote again, on the old theory of relativity, Einstein's, time and space are relations between materials. On our theory, they are relations between events. 3 years later, in his book, The Principle of Relativity, Whitehead explicitly rejected Einstein's bifurcation of nature into, quote, psychological time, which is personal, and impersonal time, as it is in nature. He also claimed to have uncovered a significant logical contradiction in Einstein's philosophical account of relativity that, if left unaddressed, threatened to undermine the possibility of spatial measurement. So he has critiques of Einstein's treatment of time, but also his treatment of space. In short, if Einstein's hypostatization of a four-dimensional geometrical manifold is to be believed, and space-time really is a four-dimensional fabric that is warped by the presence of massive objects, then the accurate measurement of distances would require precise and complete knowledge of the distribution of all masses in the universe. The problem is that this knowledge cannot be gained in advance of measurement, so we are left having to know everything before we can know anything. This is Whitehead's criticism, at least. Einstein, of course, was no philosophical slouch. He briefly mentions issues of spatial measurement raised by general relativity in several of his papers. In 1921, a paper titled Geometry and Experience covers some of this territory, but Einstein does not appear to believe that these issues raised by Whitehead represent a problem worth dwelling on, much less a fundamental contradiction in his interpretation of relativity. Again, in a 1923 paper on the cosmological implications of his relativity theory, Einstein admits that as a consequence of allowing the metrical character or curvature of space-time to be determined at every point by the matter at that point, a consequence is that this space-time must be extremely complicated. But he claims that the possibility of accurate cosmological measurement is saved so long as we believe that matter remains, quote, uniformly distributed over enormous spaces. Whitehead was not convinced. In his work, The Principle of Relativity, Whitehead writes, I cannot understand what meaning can be assigned to the distance of the sun from Sirius if the very nature of space depends upon casual intervening objects which we know nothing about. Unless we start with some knowledge of a systematically related structure of space-time, we are dependent upon the contingent relations of bodies which we have not examined and cannot prejudge. Let's get a sip of water. So to avoid what Whitehead believed was a serious problem, he built on his new event ontology to develop a set of empirically equivalent tensor equations that did not rely upon the idea of a contingently curved spacetime to explain gravitational effects. Instead, he elaborated a scheme wherein space retained a uniform structure thereby permitting the projective relations required for meaningful measurement. In place of Einstein's non-uniform space-time fabric, Whitehead offered his own theory of the propagation of gravitational potential in terms similar to electromagnetic waves, only now gravitational and electromagnetic activity was said to vibrate in an ether of events rather than the old material ether. In this way, Whitehead was actually able, I would submit, he was able to move physics closer to the unified field theory that Einstein spent the second half of his life searching for, but only by shifting from material points to creative events as fundamental to physical ontology. The radical implications of the shift to an event ontology led the physics community to reject Whitehead's approach, at least until quite recently. For one thing, accepting the fundamental nature of creative events means letting go of the quest for objective certainty that has plagued modern science since its inception. Unlike simply located particles that can be conceived of as fully present at a given instant, events are overlapping. They have fuzzy spatial and temporal boundaries, and thus only submit to approximate measurement. An event ontology is also at the center of Whitehead's attempt to heal what he termed the bifurcation of nature, which I'll return to in a moment, as the gap between the durational unfolding of an electromagnetic event and a moment of conscious experience is far easier to leap than is that between experience and inert matter. The former gap is a difference in degree or intensity, while the latter is a difference in kind. While Einstein definitively rejected the Newtonian theory of absolute space in favor of a relational model, Whitehead, I would argue, goes further by reinterpreting relativity theory within the context of a fully relational epistemology and ontology. Whereas Einstein and the physicists who inherit his way of thinking view our experience as though we are spectators gazing in upon the world from outside it, as though the phenomenological quality of lived time is just a distorted projection onto otherwise objective physical happenings, Whitehead embeds experience within the world as a relational participant essential to shaping its ongoing creative advance. How then does Whitehead's critique and reconstruction of Einsteinian physics stand in relation to Bergson's view? There is a rich literature trying to sort out the extent and nature of Bergson's influence upon Whitehead. Whitehead's first biographer, Victor Lowe, downplayed the significance of this influence, while more recent scholarship by Randall Oxier, Pete Gunter, and Karl Hausmann has amplified their relation by arguing for a deep confluence of ideas. So I'm going to explore this tension here in the scholarship. According to Whitehead, the measured clock time of the physicist and of conventional civilized life, quote, merely exhibits some aspects of the more fundamental fact of the passage of nature. On this point, Whitehead claims he is in, quote, full accord with Bergson. Bergson took notice, writing that Whitehead's 1920 book, The Concept of Nature, quote, is certainly one of the most profound works ever written on the philosophy of nature, end quote. A decade later, Whitehead affirmed in Process and Reality that, quote, the history of philosophy supports Bergson's charge that the human intellect spatializes the universe. That is to say, that it tends to ignore the fluency and to analyze the world in terms of static categories. But, continues Whitehead, Bergson went further and conceived this tendency as an inherent necessity of the intellect. I do not believe this accusation. So, Bergson created this dualism between intuition and intellect. Science works with the intellect, which is something that the human being has evolved in the course of evolutionary time, so we can navigate space with solid objects. Intuition is coming from this other evolved capacity related to instinct that he believes gives the philosopher special access to duration. But Whitehead does not think that science is necessarily limited to this type of spatializing intellectual grasp of nature. In the preface to Process and Reality, Whitehead says he was lured into his adventure in cosmology in part to save Bergson's, quote, type of thought from the charge of anti-intellectualism, which, rightly or wrongly, has been associated with it. So according to Gunter, Whitehead is not reacting to Bergson's true view in these excerpts. Bergson is not, says Gunter, anti-intellectual, nor does he believe the scientific intellect is inevitably mechanistic and bound to falsely spatialize the universe in all its attempted explanations. In his 1907 work, Creative Evolution, Bergson himself attempted to initiate an organic reformation of the abstractions of science. Whitehead's philosophy of organism, as he calls it, can be understood to have brought this project closer to fruition. Nonetheless, Whitehead and Bergson's views do seem to diverge on certain key metaphysical issues. Whether this is a divergence of emphasis or of substance is difficult to decide, since as Whitehead reportedly said, and I say reportedly because this is from notes taken by a student during his first seminar at Harvard in 1924, as Whitehead is reported to have said, Bergson must be praised for writing so evocatively about what he feels and sees, but he must be faulted for, quote, phrasing it so that you can never be quite sure what he means. One of Whitehead's apparent divergences from Bergson concerns the Frenchman's emphasis upon the continuity of becoming. In contrast, by the mid-1920s, Whitehead had come to affirm an atomic or epical theory of the becoming of continuity. So not the continuity of becoming, but the becoming of continuity. Victor Lowe argues that this is an irreconcilable difference, while Gunter and Capek insist that the divergence is only a difference in emphasis. The latter two thinkers point out that Bergson's duration was no simple continuity, but a multiplicity of overlapping rhythms. As Bergson describes his view in Duration and Simultaneity in 1922, duration is, quote, multiplicity without divisibility and succession without separation. While admitting some ambiguity due to Bergson's shifting positions across more than 30 years of writing on the topic, Elie During argues that Whitehead's epical theory of becoming is, quote, systematically circumvented by Bergson's insistent isolation of a pure experience of time from the concept of space that is abstracted from it. Whitehead's epical theory of the becoming of continuity rejects both the metaphysical fairy tale of nature at an instant, which is still residual even in Einstein's notion of the relativity of simultaneity, as well as the idea that time is simply an unbroken homogeneous flow. Instead, Whitehead took note of the discontinuity evident in the new quantum theory, as well as aligned himself with William James's notion of a concrete time that grows, as James put it, dropwise by discrete pulses of perception. In Whitehead's mature philosophy, our experience of apparently continuous becoming is thought to be composed of historical roots of what he calls actual occasions of experience that each arise from the settled past to achieve their subjective aim in the present before superjectively perishing into the future to be resurrected by subsequently concressing occasions. Concrescence is a phasic process, but it does not occur in an already actualized geometrical space-time continuum. Rather, Whitehead describes a universe wherein vast societies of electromagnetic and gravitational occasions are actively weaving and reweaving the fraying fabric of space-time as a field of potential relationships. Whitehead views space and time as abstractions from concrete events. The events or actual occasions are what is concretely actual, while space-time is a field of abstract possibility within which they can relate. Some Bergsonians may be tempted to view Whitehead's epical or atomic theory of space-time as another intellectual falsification of living duration. But Whitehead's understanding of space-time as epical is not another cinematographic model of reality, where juxtaposed instants are translated into a cartoon-like illusion of the creative flow and musical rhythm of our inner life. Whitehead affirms the reality of a continuous transition between occasions of experience, but because his speculative scheme is an effort to reform the scientific intellect so that it acknowledges the evidences of intuition, he asks us to imagine another fundamental form of process alongside that of transition, namely the atomic process of concrescence. So reality can be conceived of as continuous in the social coordination achieved by transitions between actual occasions of experience, which, though they each atomize the continuum, nonetheless remain linked together in an abstract field of real potentiality. Reality can also be conceived of as epochal, as the given facts established by past actual occasions are taken up into each newborn drop of experience, wherein, through some creative intervention upon the past, a novel actualization of value is achieved, which then perishes to gift its unique value intensity back to the cosmic community. There is continuity and there is individuality. Concrescence is thus a process whereby, as Whitehead famously puts it, the many become one and are increased by one. There is established, through the synthesis of inherited public feelings and anticipatory private aims, a cumulative movement or creative evolution from past to future along multiple more or less overlapping historical routes of experience, or world lines in Einstein's terms. There is a becoming of continuity rather than a continuity of becoming in this iterative growth process, which is achieved occasion by occasion through individuating acts of valuation. The space-time continuum, like living organisms, thus grows in a cellular way. As Whitehead put it, quote, "Time and space express the universe as including the essence of transition and the success of achievement. The transition is real and the achievement is real. The difficulty is for language to express one of them without explaining away the other." Their possible divergences aside, Whitehead shared with Bergson the desire to reimagine the relationship between philosophy and science so that the latter would no longer succumb to the temptation of, quote, heroic feats of explaining away. Whitehead wrote, I think, in The Function of Nature, that every scientist is supposed to deny that they have a metaphysics, but what they really mean is that they don't like having their metaphysics questioned. So Whitehead's response to Einstein's reductionistic metaphysical interpretation of the physics of space-time was really aimed at a philosophical postulate that long preceded Einstein, the so-called bifurcation of nature that I've mentioned, which was first introduced by Galileo in the 17th century. In Galileo's terms, this bifurcation was a division between primary quantitative or material characteristics and secondary qualitative or mental characteristics of reality. This bifurcation is the founding metaphysical gesture of modern scientific materialism. For centuries, it proved to be a tremendous boon to natural scientific investigation, freeing researchers from scholastic metaphysics by encouraging parsimonious explanations based in mathematical calculation and empirical measurement. But as with all abstract models meant to capture some aspect of concrete reality, its limits will eventually be reached and must be understood and accepted. While immensely useful for describing the widespread regularities and settled facts of physical nature, the bifurcation between primary and secondary characteristics not only severely handicapped inquiries into fundamental ontology, it also distorted the biological and psychological sciences, where the role of perceptual evaluation and conscious decision-making can no longer be ignored. Disturbed by Einstein's dismissal of the place of consciousness in the cosmos, and remember Einstein said, "For us believing physicists, the distinction between past, present, and future is only an illusion, even if a stubborn one." Disturbed by this statement, Whitehead realized he needed to challenge this founding metaphysical gesture and search for a more adequate scientific worldview. In Whitehead's new organic philosophy of nature, human perception and agency come to be understood as especially intense expressions of, rather than miraculous exceptions to, the more habit-bound vibratory rhythms of the physical universe. So rather than having to separate humanism and materialism, Whitehead's trying to find a way in which our human sense of experience can be understood as continuous with simpler forms of experience that are pervasive throughout the cosmos. It's a so-called panpsychist or pan-experientialist position. Replacing the old gesture of bifurcation, Whitehead offers the following founding proposition for a new kind of natural philosophy to undergird physics. I quote, "For natural philosophy, everything perceived is in nature. We may not pick and choose. For us, the red glow of the sunset should be as much part of nature as are the molecules and electric waves by which men of science would explain the phenomenon. It is for natural philosophy to analyze how these various elements of nature are connected." So I'll continue here to quote Whitehead at length because this issue of the bifurcation of nature, I think, is central to his criticisms of scientific materialism, and I think they can really help clear up a lot of the conflicts that we've seen surface so far in this conference. So Whitehead says, "In making this demand that everything perceived is in nature, I conceive myself as adopting our immediate instinctive attitude towards perceptual knowledge, which is only abandoned under the influence of theory. We are instinctively willing to believe that by due attention, more can be found in nature than that which is observed at first sight. But we will not be content with less. What we ask from the philosophy of science is some account of the coherence of things perceptively known. What I am essentially protesting against is the bifurcation of nature into two systems of reality, which, insofar as they are real in different senses. One reality would be the entities such as electrons, which are the study of speculative physics. This would be the reality which is there for knowledge, although on this theory it is never known. For what is known is the other sort of reality, which is the byplay of the mind. Thus, there would be two natures. One is the conjecture, and the other is the dream." End quote. This is from the Concept of Nature. Healing the bifurcation of nature allows natural philosophy to avoid committing what Whitehead called the fallacy of misplaced concreteness, which is what Einstein falls prey to when he dismisses lived experience as a dream and falsely concretizes a conjectured geometrical model as though it was identical to actual nature. Of course, as the history of modern science has made evident, appearances are often deceiving. Taking lived experience seriously doesn't mean accepting reality as it first appears to us. The Earth is not flat and is not orbited by the sun, for example. As Whitehead says in the excerpt above, we instinctively search for deeper realities and are not satisfied with superficial appearances. There is always more than what at first meets the eye. But the dismissal of our lived experience of temporal becoming in favor of an atemporal theoretical model asks us to accept that nature is less than our experience reveals. To dismiss lived time would be to lose the thread of experience that makes scientific reflection and experimentation possible in the first place. Even the mind-bending paradoxes of contemporary theoretical physics are, according to Bruno Latour, quote, "child's play in comparison with the multiplicity and complexity of the dimensions that are simultaneously accessible to the most minimal experience of common sense," end quote. Inheriting the protests of Bergson and Whitehead, Latour invites us to return from outer space to re-inhabit the solid ground of our common sense experience. The interlacing ecological complexity of our everyday experience of standing on Earth beneath the sky, enveloped within an atmosphere alongside many millions of unique species of plants, animals, and other human beings, makes even the mathematical quantum and relativistic realms of theoretical physics look like toy models in comparison. The world of common sense experience is even more difficult to fathom than the abstract micro and macroscopic worlds modeled by physicists, since, as Latour reminds us, the former, quote, "has been infinitely less explored than the other." So we have as much to learn from artists and philosophers as from scientists about the textures of this world, our world. By rejecting the bifurcation of nature, Whitehead is also rejecting the idea that time is merely inner, whether transcendental or psychological, leaving the physicist to reduce the objective external universe to a timeless block. While in his response to Einstein's relativity theory in duration and simultaneity, Bergson seems to confusedly present his theory of duration as a phenomenological defense of, quote, direct and immediate experience, The Bergson of earlier works, like Matter and Memory and Creative Evolution, affirms that duration reaches beyond the subject and is also intrinsic to the evolution of all life on Earth, and indeed to the unfolding of the physical universe. As Bergson put it in Matter and Memory, there is another pathway open to philosophers after the transcendental critique of experiential time as merely a form of inner intuition. That is, they must seek experience at its source, or rather, above the decisive turn where, taking a bias in the direction of utility, it becomes properly human experience. End quote. Contrary to the misreadings of some Bergsonians who suggest that Whitehead anthropomorphically extends Bergson's élan vital to supposedly inorganic matter, and like the Bergson of earlier works like Matter and Memory and Creative Evolution, Whitehead's process philosophy attempts precisely such a return to the source to uncover a more primordial form of temporal and spatial experience that can no longer be anthropocentrically claimed as the unique province of human or even living beings, but which must be understood to infect the universe to some degree at every scale of its actualization, from its earliest to its latest evolutionary expressions. Whitehead tells us that the primordial element of the universe itself is a, quote, vibratory ebb and flow, an energy or activity that is nothing at any instant and that requires its whole period to manifest itself. This vibratory activity unfolds through its concrescent phases of sensitive reception and creative expression. Crucially, Whitehead unambiguously rejects the dualism that Bergson sometimes slips into by affirming that, quote, ultimate concrete fact is an extended process. He continues, if you have lost process or lost extension, you know you are dealing with abstraction. Extension is essentially processual, and process is essentially extensional. This is Whitehead's metaphysical reformulation of a now even more general theory of relativity. So I have until 4:20, 4:15? 10 more minutes?
And 9:34.
Okay. So if we think back to what Yuval was describing when he spoke of William James and his phenomenological descriptions of human consciousness, we can think of James as a realist. Certainly he was critical of idealism. He referred to himself as a radical empiricist and wanted to arrive at an ontology that was rooted in what he called pure experience, and eventually arrived at something like the neutral monism that was a term that Russell came up with, where at the fundamental level, reality is neither mind nor matter, but something neutral between the two, which for James was pure experience. And Whitehead is trying to pick up where James left off. He describes James as the American Plato, in the sense that he wasn't very systematic, but he was so generative and creative. He set out new problems for philosophers to work on in the 20th century. He thought that Charles Saunders Peirce was the American Aristotle, even though the order is reversed because Peirce was more systematic. But Whitehead wanted to take James's brilliant insights, which were not systematically arranged, at least when he went into philosophy. I think his principles of psychology is more systematic. But Whitehead wanted to expand beyond this humanist perspective, to reimagine what the universe studied by science is like, and indeed to reform science, rather than just saying, well, we have human experience over here, and as long as scientists don't try to reduce away that experience to some mechanism, then scientists can keep studying the universe as a mechanism. Whitehead wanted to critique the abstractions of science and to bring forth an organic science that could take time seriously, the time of our experience, and understand duration as something that applies as much to a photon or an electron as it does to a moment of human experience. Certainly, human experience is far more intense in Whitehead's terms. It's also, in his terms, sheltered by societies of other actual occasions, which act as filters and amplifiers to make our experience more relevant, and these filters evolve over the course of time. But still, Whitehead's trying to preserve this continuity, and so his ontology is sometimes called panpsychism, which in academic philosophy, maybe 10 or 15 years ago, was dismissed rather quickly. Famous philosopher Colin McGinn once said that there's something somewhat hippie-ish about it and that you have to be stoned to believe it. And he might be right, but more recently, it's no longer a taboo subject, and the difficulty of the mind-body problem, the difficulty of the bifurcation of nature has become so pronounced for people researching consciousness and its relationship to the brain that panpsychism is all of a sudden being taken seriously again in the philosophy of mind, and I think it should be taken seriously in physics as well. I would like to request from the physicists in the audience your reaction to Whitehead's criticisms of Einstein, in particular this cosmological measurement problem. I'm not a physicist, and so I read Whitehead and I've presented his view, but it doesn't seem that many physicists take this as a serious problem. Why did Whitehead think it was such a serious problem? I'm curious to know what the physics community thinks of his criticism there. And I'll leave it at that. Do we sit up here?
Thank you. Same as you like. So, questions? Ale.
Okay.
Thanks for your talk. I have a question which really addresses Whitehead's biography, because I think I once read in Russell, one of Russell's books, that he lost his son in the First World War.
Yeah.
And Russell thinks that that event really changed his bent of mind. And of course, this is a biographical detail that, of course, may have no weight in really considering his second phase of philosophizing. But what do you think about this?
Well, Whitehead and Bergson were good friends, Whitehead and Russell were good friends, and Russell even lived with Whitehead and his wife Evelyn for some time, I think, during the war. And they kind of split because of, Russell was arrested and because of his pacifism, and Whitehead's son was in the war fighting, and so that created a rift between them, I think. But I don't really buy this statement that Whitehead only started to believe in God to cope with the loss of his son Eric, who was in the Royal Air Force. Whitehead, Isabel Stengers argues, for example, that Whitehead arrives at the divine function, to think of this in a mathematical way, or this concept of God, in the course of working out his metaphysics because of the metaphysical role that God plays. And Whitehead is very critical of the religious traditions that have imagined, whether it's Judaism, Islam, or Christianity, that have imagined God as an exception to the sort of metaphysical rules that govern everything else in the universe, or to the physical rules that govern everything else. He wants, in Process and Reality, he says he wants God to be the prime exemplar rather than the miraculous exception to the metaphysical system that he's outlining, so that God is an actual occasion or an actual entity like all other actual entities. There's only one genus of actual entities, and that includes God. It includes, the occasions of experience associated with animals and plants, and it includes a far-off puff of energy in empty space. So his God is not at all the sort of God that would answer to a religious need in this way. He does have some sense of a divine memory that doesn't anything that happens in the universe, but there's no sense of like, he leaves open the question of personal immortality, for example. He says his metaphysics doesn't decide that question for us. He wasn't trying to, engineer a universe wherein his son's soul would continue to exist in some afterlife. So I don't buy Russell's statement. I don't think that's why God became important for Whitehead.
Thanks.
Yeah.
So there is another question.
About Whitehead's worry about distances in space, the answer is already given by the Greek ancient astronomers, and it relies on the wonderful fact that as gifts of nature we have measuring rods. You take two bits of stick and you find they have the same length by placing one on top of the other. Then you go off somewhere and you take one a long way away, you bring it back and you find it lays exactly on top of the other one. And if they don't, you can always find a reason why that isn't the case, because one of them got stuck in a bit of fire and a little bit got burnt off at the end. So you can find a perfectly good explanation why that doesn't do it. Now that's a gift of nature that rods exist like that. Now the basis of all astronomy, everything was discovered by the measurement of angles. Angles are measured very easily. You can do that as a child, and I've done this with a daughter of 12. You just take one stick and you put it right angles to another stick, and then you knock in nails at an inch each way along each side like that, and then you hold it up like that, and you see on your retina you have the projection of that cross piece with the nails on it, and you see the stars on that there, and that enables you to measure angles between the stars. And the ancient astronomers developed methods for working out how the planets moved relative to the Earth and the Moon and the Sun, and then Kepler took it further using essentially the same methods that Ptolemy had developed, or Copernicus did, and they worked out exactly how far the planets away were from each other. Copernicus has this wonderful saying that Ptolemy's ancient astronomy was like someone who'd depicted all the limbs of different animals but hadn't put them together to make a beautiful creature. And that's exactly what Copernicus did. He could tell you the order of the planets and how far they were from each other. And this completely solves. Whitehead just was completely unaware of what the ancient astronomers had done. Otherwise, and the basis is the gift of nature, why there are measuring rods. And Einstein just accepted that there are measuring rods given to us by nature, and there are clocks given to us by nature, and that is really all that's needed. And I'll actually tomorrow present a theory of how actually rods and clocks arise, which didn't exist at the Big Bang but do now. So I think actually you can forget Whitehead's worry.
I certainly understand the local, examples that you're giving here on Earth with measuring rods and perhaps astronomy local to the solar system, but so the issue of not knowing how space curves in advance in a cosmological space, say between galaxies.
Well, you don't need to know the whole, the key thing about Einstein, as for Newton, is that there are local inertial frames of reference. And Einstein's equations are not actually about the whole of the universe, they're about what happens locally. All you need to worry about to verify Einstein is how the sun curves space locally compared with a sort of a more or less flat background. The part of Whitehead's worry was that Einstein was still in a very confused way trying to implement Mach's idea, where matter determines geometry in a way which turns out to be mathematically inconsistent. Einstein was totally confused about this, actually. At the end of his life, he said, Mach's ideas, a moment's reflection will show that it's all nonsense, but you can dismiss it. But he himself had spent about 20 years thinking it was wonderful, and he created his general relativity to implement those ideas, and then he just completely rejected it. Einstein was, on that respect, I would say, very confused. And
well, if
particularly
Einstein's
that
confused,
passage
makes
that
me
you're
feel
picking
better.
up was where Whitehead had picked on a particular point where Einstein was particularly confused about Mach's principle.
When Whitehead and Einstein met at Lord Haldane's home in 1921, Whitehead tried to explain this to Einstein, and there was probably a language barrier as well, but Einstein said, "I'm very confused by what you're trying to say to me." So,
yeah, but Einstein was also himself extremely confused about Mach's principle at the
Right.
time. He gave a final formal definition of Mach's principle in 1918, which 30 years later he admitted was mathematically inconsistent.
Thank you.
Kristen?
Thank you very much. I'm very interested in the connection to Ravelli's work, and if I've missed that part in your talk, I want to profusely apologize before I even start to ask the question.
No, I didn't have time to go into it.
That's what it seemed to me, that in the abstract, you suggest that there's an interesting sort of confluence between ideas expressed by Ravelli and Whitehead, and I would be very, very interested to hear what you think these, the grounds for thinking this are. And also maybe in what sense Ravelli's particular approach stands apart from other approaches to quantum gravity, in which this may not be the case then?
So someone this morning said that Ravelli's view is somehow accepting the block universe, but he explicitly rejects it in at least the works that I've read in his latest textbook and in Order of Time. So he's rejecting the block universe, and he's saying that space-time emerges from this network of quantum events. Similarly, Whitehead says that space-time emerges from a network of actual occasions. Now, we have to be very careful not to rush to equate a metaphysical idea, like Whitehead's actual occasions or actual entities, with a physical idea of a quantum event. So we have to be careful here, and really what I hope to do is start this conversation where Whitehead shares the view that the time and space of our everyday experience is a kind of abstraction. Ravelli says that it's an approximation of something that's way more complicated. Whitehead will say that our visual experience of a projected space is our most abstract way of accessing the world. And so the space that we think exists because of our eyes is only one thin slice of the full breadth of reality. But he says we have other, as Yuval was saying, phenomenologists and James and Bergson and others have always pointed out that we have more than just sense impressions. Whitehead would say that our primary mode of perception is what he calls perception in a mode of causal efficacy, which is a form of bodily perception. So he would say we primarily inhabit the world at this level of primitive emotion, where we walk into a room and people are arguing. Before we even get cues, visual cues or auditory cues, we feel something. And he thought that these emotional feelings were equivalent to the vectors of energy described by physicists. He really makes that equivalence. When we talk about what Ravelli means by a network of quantum events and spin foams and all of this going on at the quantum level, from a Whiteheadian perspective, we would have to say that this isn't just a mathematical operation unfolding. If it's true, if Ravelli's version of quantum gravity is true, then there must be something it is like, that it feels like to spin foam. There must be some aim being realized in that activity. It's not just number crunching. And that's probably too far, way further than most physicists would want to go. Probably Ravelli too, though, if panpsychism makes more sense when you're stoned, Ravelli has written about psychedelic experiences, so maybe he's open to some of these ideas, I don't know. LSD, yes.
No, I don't know. I don't know how far we can go.
let's put it this way, a philosopher can interact with physicists and scientists, but they should be careful in using categories that could create a relationship. If you interpret vectors and use emotions, I think it's very difficult that every scientist can follow you. So science has developed an idea of the world. This is what science is. It's an idea. It's our idea of the world. The best we can provide today in the sense that it describes corners that are beyond our daily experience, corners that are very far away from our daily experience at the microscopic level, at the macroscopic level. And this vision of the world, of the universe that surrounds us and ourselves, has a language, has categories, and you have to take serious these categories and maybe criticize these categories as scientists do. But if you try to, I don't know, mix these categories with other categories that have nothing to do with this, this is a game that doesn't work.
Yeah, I mean, I guess I'm trying to start a conversation, not end a conversation. You know, this isn't the final word. You know, I think one of the things that I inherit from Whitehead is not just a process ontology, but a processual kind of open-ended way of knowing, a process epistemology. So I think I want to be careful mixing categories, but I also want to make suggestions. You know, if I think you said science is about an idea of the world, I like to say science is primarily about model making and model testing, right? And the danger occurs when the models are equated with the reality as though
Reality
it's a philosophical.
It's a difficult word.
It is.
You cannot explain.
Well, that's why we shouldn't equate our models with it.
We cannot use reality. Is difficult to describe,
Mm-hmm.
to define.
Mm-hmm.
Better not to use it because otherwise we enter.
As a scientist, you mean?
No, in general. In general. You cannot tell me what is this glass of water. You are not able to describe what it is. And so it's difficult, is a concept difficult to be described. So it's better that...
What is matter?
It's better that we, science is our problem. So we can describe our problem because it comes from our brain.
Well, because you built the model, right?
So it's a theory, it's a model that interacts with something and is tested. This model can be completely wrong. It's the model that we use to move around in this world. And this model could be criticized, could be discussed, but it's difficult to discuss this model putting it on the same level of anything. A completely different approach which is based on nothing, basically, just a speculation, just an idea. This comparison is impossible.
Yeah, I think philosophers must be in conversation with physicists and other scientists, but a philosopher isn't going to give up the word reality. So, you know...
It's a spurious word. It's not well defined. Philosophers are known to be precise in defining the words.
Sure.
And so this word cannot be very well defined by philosophers. This is why I don't like to use it.
Okay. Yeah.
A follow-up on what was just said. I totally agree with reality. A little less with vector, because so Whitehead wrote articles about vectors in the fundamental sense. I mean, we're not speaking about vector space and quadrivectors. The very concept of vector can be explained without too much technicality. You know? The idea that you can join direction and the notion of intensity or something that can be quantified in some way is in itself an invention that can be exported if you do it carefully. I don't see any objection by principle why you couldn't export it to the space of emotions.
Well, this is your method.
You have to be careful. You just said it, but why not?
Yeah. This is your method of pilfering, right? Yeah. Well, it's only day one, so the conversation continues, right? Is there a question in the back? One more? No?
Qual è l'ordine?
Do we have time? I think.
Yes.
No, I totally agree with Guido's remark about reality. I mean, we perform construction of objectivity by friction on reality, whatever the reality is. And the constructed objectivity is a perspectival matter. What I'm very surprised at so far, except in a few words by Lee During, science here is only physics. You know, there are plenty of papers like saying the reasonable effectiveness of mathematics and natural sciences, horrible paper, empty stuff, but it only mentioned physics as a natural science. Even the fantastic book by Hermann Weyl, Philosophy of Mathematics and Natural Sciences, in his first version, the only science is physics. In the 49 revision in English, he has few pages about biology. As a mathematician working in biology since about 15 years, I'm afraid that also biology is a science. And particularly the theory of evolution is a very robust, a beautiful science. And there is an intrinsic, constitutive theory of time. I think this should step in the debate somehow in some way. Because again, the perspectival views we have on organisms radically changes exactly on the issue of time, which goes from being a parameter, as it is at best in physical theories, to an operator, which is constitutive of the very structuring of biology. You cannot define an object in biology without a time perspective, evolutionary or ontogenetic. So, I mean, it is so crucial that I'm also worried that the author of L'Evolution Créatrice is in the debate focuses on time of consciousness that may only be forced into a vision of biology. He was so careful, Bergson, about life, doesn't put the issue at the core of the debate while it should be. And again, I encourage my colleague physicists to consider that also biology is a science with its autonomous perspective. In the same way as there is no way to talk of hydrodynamics in terms of quantum mechanics, there are partial bridges, partial results, but there is no way. And as I know that there is a lot of water in organisms, there is no way to talk of organisms in physical terms, to deduce properties. Of course, organisms must be compatible. They must be compatible, unfortunately, with both quantum physics, hydrodynamics, classical physics, and these fields are not unified. So, and the reason for lack of unification is exactly time. So this poses totally different perspective, and I strongly encourage my colleagues, when they refer to science, to consider that it is not only physics.
I completely agree. I have studied the theoretical biologist Robert Rosen's work, who says that biology is actually more general than physics, and that the current physics, because organisms are not entailed by its laws, must be it's too specific. And I do think, there's a way in which biology should be at the center of these questions, because we are biological organisms, and if we were not alive, there would be no physics, or at least no study of physics. So everything that we know about the physical universe is in some way mediated by the fact that we are organisms. And I think Whitehead is trying to make an even more general claim. He calls his philosophy the philosophy of organism, because he wants to conceive of the whole cosmos as, in some sense, organic, where the parts of it that appear mechanistic are just that. They're parts, but the whole is organic. So I completely agree. I didn't mean to equate science and physics. One more?
Curiosity, given Leibniz's panpsychism, is there any reference in Whitehead's work to Leibniz?
Certainly, there is.
I think even this idea of vectors expressing emotions, I think it's in Leibniz already, or something very, very close to that.
So the important difference, so for Whitehead, like Leibniz, the universe is made of perspectives, but for Leibniz, his monads, as opposed to Whitehead's actual occasions, they have no windows. They're closed. Their entire history and future is sort of encoded within each of them, and God arranged all the monads in advance so that they appear to have relationships with one another, but in Leibniz's system they don't. Whereas Whitehead's actual occasions are almost all window. So the vectors do penetrate. The occasions are all internally related with one another directly, not mediated by God as in Leibniz. So there's some similarities, but that important difference. Whitehead's monads are exchanging feelings with one another. There's a real causal exchange going on, and Leibniz's monads have no such causal exchanges.
Okay, so let's thank Matthew again. Okay, so we'll now take a 15 minutes break.
So time to start. Okay, welcome back. Our next speaker is Etienne Klein, and the title of his talk is "Who is entitled to talk about time?" Etienne Klein is a physicist at the CAA, the French Atomic Energy Commission, and Saclay near Paris. He also is a director of research laboratory on matter science and at CEA, and his research interests include the foundation of physics, the interpretation of quantum mechanics, and of course the question of time in physics and the relationships between science and society. He is an author of several books, 4, and at least 2 papers. What does the arrow of time mean, and what does the arrow of time stand for? So it's a pleasure for me to introduce Etienne, and the stage is yours.
Thank you. The title of my talk is "Who is entitled to talk about time, philosophers or physicists?" Or I could add physicists and philosophers, or philosophers and physicists and others, or none of them. Okay? First of all, I would like to thank the organizer for their invitation and tell all the pleasure I have in attending this meeting. And I would like also to apologize for my French accent. The debate about this question has already begun, but I intend to ask a very few naive questions about time, because I think we have to be honest. We reflect on time, but we never really know what it is we are thinking about. Is time a substance? Is time a fluid? Is it an illusion? Is it a social construct? Is it a mathematical parameter? Is it a psychological factor? Many common sayings suggest it is a physical being, not an object, but a physical being, but others imply the opposite. For example, they imply that time is a product of consciousness, or just a word that we use to say this or that aspect of natural processes. Who can actually say, with any certainty at all, whether time authors events or is in fact created by them? And who can say that they know enough, with enough certainty, to explain what clocks are really telling us when we say they are telling the time? We all feel entitled to answer these questions, but we generally end up with a model. One person says that time stops when everything stops changing. Another person says that time still passes when nothing happens. And yet another says that it only passes in our consciousness, whereas another person says that time accelerates. The least we can say is that there is no harmony of viewpoints on time, as we can see today. So, fundamentally, what is time really like? Is it how we think we perceive it or experience it? How it is mathematically represented by physicists? How it is thought of by philosophers or others? A priori, it is to philosophers that we need to turn, since the question of time has been and continues to be one of their main preoccupations. Haven't many of them come up with clever, coherent systems for thinking about time more clearly? Indeed, they have. Aristotle, St. Augustine, Leibniz, Kant, Husserl, Bergson, Heidegger, to name a few. But nevertheless, anyone whose only resort on the subject of time is philosophy will come up against two problems. The first one is a classical problem due to the very essence of philosophy. It is the fact that not all philosophers agree with one another. In their discourse, time is sometimes the principle of change, sometimes it is a static arena filled with what has already happened, waiting for what is going to happen. Sometimes it is seen as a purely physical being, or alternatively, as an invention of the imagination, or a product of certain culture, or even as an illusion. So there are choices to be made. But on the basis of what criteria? The elegance of the proposed system, its appeal, its rigor, its plausibility. Who came up with this system? That has to be specified. The second difficulty, which is related to the first one, is the fact that philosophy itself is divided on the question of time, in the sense that it places the different doctrines on two very distinct categories. In one category, time has to be thought of as a simple order of anteriority or posteriority, with no preference to the present moment or to the consciousness of any observer, or even to the mere presence of an observer. The only thing that exists in this category is temporal relationships between events. Time, therefore, appears to be an order of successions in which sequences of events are objective, definitive, independent of us. For example, if I say Newton was born before Einstein, I say something which is true and which will remain to be true at any other moment. In the other category, time is seen as a passage, the passage of a particular moment, the transit of the present to the past, and the future to the present. Because this movement can only be described if there is a subject present to perceive it, time appears to be not just a chronological order, but an endless dynamic motion, the driver of which is linked to subjectivity. In this case, the truth of a sentence will depend on the moment where it is said. For example, if I say the weather is beautiful, it is true now, but can become false tomorrow. The question is, towards which of these two doctrines should we lean? It's difficult to answer for at least two reasons. The first stems from a fact with which it's difficult to argue. The idea that time does not exist in itself, does not exist without a subject to perceive it, must be confronted with well-documented fact. In the last century, scientists have established that the universe is at least 13.7 billion years old, and that humans only appeared a mere 3 million years ago. What do these figures tell us? That most of the universe time has clearly been spent without us. Consequently, if we argue that time is dependent on there being a subject and could not exist without one, a quasi-logical problem arises. How did time pass before we came on the scene? Many authors have pointed out this paradox that Quentin Meillassoux, a French philosopher, called the paradox of ancestrality. saying that time exists only within the subject, or that time only as subjective reality, surely makes it difficult to explain the appearance of the subject within time. The second reason relates to the fact that if, on the contrary, we take the view that time exists and passes independently of us, we still need to identify and characterize what drives time, that is the mechanism that makes one present moment appear and another present moment appear immediately after it, pushing it out and taking its place, before yet another present moment pushes that one into the past, taking its place in the present, and so on. Theoretical physicists are striving to find the source of this hidden dynamic that is the engine of time, especially at the frontiers of quantum physics and the theory of general relativity, but they have not yet properly identified it. Where does this engine come from? Is it a property of time itself, or is it linked to a global property of the universe, as Julian Barbour may explain it tomorrow? To conclude this first part, if we decide that time depends on the subject, we face a peculiar problem. And if we decide that it does not, we face another peculiar problem. This refers back to a question raised by Bergson in his book Duration and Simultaneity. How can something which is successive, he wondered, be engendered by points that are present all together, that are juxtaposed in a static way in some space? But what mechanism do points on a straight line through space manage dynamically to become temporal? The physicist Lee Smolin recently drew attention to this puzzle, which he sees as a major conceptual difficulty blocking the progress of theoretical physics. He wrote, "A motion through space becomes a curve on the graph. In this way, time is represented as if it were another dimension of space. Motion is frozen. We have to find a way to unfreeze time, to represent time without turning it into space. By representing time as a line of points resembling those in space, we change its very nature." Bergson wrote, "From the moment where you attribute the least homogeneity to duration, you introduce space. Hence, drawing the time axis as a line with an arrow becomes an almost monstrous act. By doing this, we make successive moments which by definition cannot all be present at the same time, coexist spatially, i.e. exist together in the same present moment. Essentially, we represent moments in time in the same way as if they were points in space, which changes their specific nature." Emmanuel Kant, in his Critique de la Raison, had already identified these strange situations. He wrote, "We represent the succession of time by a line progressing to infinity, in which the manifold constitutes a series of only one dimension, and from the properties of this line, we infer all the properties of time, with this one exception, that while the parts of the line are simultaneous, those of time are always successive." Stopped in our tracks by all these terrifying questions, we could take some intellectual comfort from reflecting on the fact that time is only a word, a name, the meaning of which can be found by some accurate analysis. Hence, it would be possible to conduct a quasi-scientific research into what it actually means the meaning of this word is essentially nothing more than the ways in which we use it. Therefore, we just have to ask what our sentences are attempting to convey. But the problem is that the way we talk about time is heavily dependent upon the way our existence relates to it. The temporal phenomena that we are subject to or witnesses to make us believe time looks like them. We assign to time as many different descriptors as there are different experiences of time. So we talk about time being empty on the basis that nothing is happening. Time speeding up on the basis that the pace of our lives keeps getting faster. Time being cyclical when similar events repeat themselves. We speak of psychological time, meaning that there is a sort of second, independent time that passes without reference to the time shown by the clock. We also speak about biological, geological, cosmological time, and so on. It's as if time, its essence, becomes confused with the different use made of it, or its different circumstances or guises. But if time has so many guises, can it really have the slightest consistency of its own? Is it still conceivable? Doesn't the act of projecting too many disparate ideas on time kill the very idea of time? Time is also the victim of an abuse of language. It is now used to refer to succession, simultaneity, change, future, duration, urgency, waiting, speed, aging, and even death. This is obviously too much for a five-letter word to bear. Cleaning up the verbal situation, to use Paul Valéry's words, is therefore what is needed. How do we do this? And on what basis? How can we use as the foundation to make this critics of verbal situations? Physics, which has been so effective since it grasped time mathematically, making it a key parameter of its equations, is certainly one way of performing a semantic cleanup. To do this, we need to try to translate into ordinary language what the most fundamental physics equations would say about time if they could talk. It's a tricky and uncertain task because equations cannot speak for themselves, but if it's done properly, it can identify messages that can be profound and powerful, and I will come back to this point later. But if we go down this path, one doubt arises about the words used to express the Newtonian revolution, which marked the birth of modern physics. As you know, Newton introduced into physics what would become the variable t in equation of dynamics, and it chose to call it time. We have become so used to this representation that it seems completely natural. It seems natural to the point that it no longer occurs to us to ask this simple question. On the basis of what prior conception of time and what line of reasoning did Newton choose this name? And on the basis of what prior knowledge did he recognize time in the shape of a mathematical variable? In his writings, as far as I can read them, Newton was not really clear on the subject. Logically, he should have given the parameter t a different name because the physical time that he invented shares none of the properties that we ordinarily attribute to the idea of time. This time t is intangible, abstract. It has no rate of flow, because given it, one would assume that the rate of passing of time varies in relation to the rate of passing of time. Nor does it share any of the characteristics of the temporal phenomena that take place within it. It is homogeneous in the sense that all instants of time have the same ontological status, which means that time does not change over time its way of being time. It does not depend on itself. Finally, it is imperturbable, indifferent, impassive, in the sense that nothing can disrupt its course. Is that real time, or just a poor caricature of it? Doesn't the parameter just refer to an incomplete version of time, or does it represent it in the right way? This question led to another question. What would have happened to the way we think about time if Newton has decided to call the variable t by a different name, for example, by the name trick? If this had happened, physicists would not have talked about time in the same terms, and it would never have occurred to us to ask them about it. They would have organized symposia about this trick that appear in their equations, and for their part, philosophers, historians, sociologists, and so on would have carried out talking about time without having to worry about the discoveries of physicists. In short, if Newton had not made this rather arbitrary decision, our lexical world, and therefore our intellectual situation, would have been quite different today. As you all know, Newtonian time is physically dead since 1905 with the publication of Einstein theories of relativity, but this did nothing to resolve the semantic questions I ask. In fact, far from being arguments just for the sake of argument, they are debated today even with greater seriousness. To describe gravitation and the other three fundamental interactions within the same formal system, theoreticians come up with all sorts of hypotheses about space-time, and their calculations are turning both its structure and its properties. Space-time could have more than 4 dimensions. It could be deducible from an underworld that is more fundamental than it. It could be discontinuous, and so on. The question that arises for them is therefore this: what are the characteristic properties of time, the ones that should be given to it a priori, by which it can then be recognized in the form of this or that variable or mathematical construct? To recognize time in a set of equations, or to detect its absence, surely it is first necessary to know what it is. But how do we find out what it is at the outset, before having a physical theory identifying its nature and its properties? It suddenly looks like we are at the start of a vicious circle. It is particularly vicious in that some theoretical physicists argue today that we could do without the idea of time altogether, on the grounds that it does not seem to appear in the most fundamental equations, or that it is only an emergent property, that is, it is deducible from a certain spatial scale, from an even world where it it does not exist. After all, why not? We could still need to check that even though new equations seem to have made it disappear, it has not fled elsewhere, not put on a mask, not dressed itself in some other garb, such as that of dynamic variable, causality, or relationship of order between events. To be able to certify that time has indeed dissolved into thin air, we first need to say exactly what the thing we call time is, and also explain how our minds came to create such a fiction, to believe in such a ghost. But if we choose to ignore all these difficulties, that is, if we decide to accept that physicists' time is perhaps not real time, but at least a more genuine time than others, a time that is more in contact with reality, then a new perspective appears. The new formal systems of physics could become a theoretical basis from which we can undertake a critique of the language of time, or indeed challenge some of our ways of talking and thinking. One example of this is that physics equations do not agree with the quasi-systematic link we make between time and becoming. Or at least its formal systems make a clear distinctions between what we call the course of time and what we call the arrow of time. The course of time is what establishes a distance between moments in the past and moments in the future. In time, tomorrow is not at the same place as yesterday. They are separated from one another by a certain duration. So defined, the course of time expresses the irreversibility of time itself. It is not possible to reverse the earlier-later order of the events. The arrow of time, on the other hand, is the manifestation of the becoming. It expresses the fact that some physical systems change in an irreversible way. They will never in the future return to the state they were in the past. When it is present, the arrow of time happens in addition, dressing up the course of time, which is irreversible by its very essence, with phenomena that are also irreversible. The irreversibility of phenomena seems to contradict the fundamental equation of physics, because these are all reversible. I mean that their form does not change when you reverse on paper the direction of the flow of time. So instead of going from past to future, it runs from future to past. But while staying within the framework of these equations, physicists, the first one is Boltzmann, have ended up identifying possible explanation of the arrow of time. They all assume these explanations, the prior existence of an established course of time within which phenomena that can occur in both, within which phenomena that cannot occur in both directions take place. In conclusion, the course of time is accounted by physicists in ways that never coincide with ways in which the arrow of time is justified. This indicates, or shown, or even demonstrate that the course of time and the arrow of time are two distinct things in contemporary physics, except if we take into account general relativity, and Julian Barber will talk about this tomorrow. What I mean there is that the irreversibility of phenomena does not come from the irreversibility of time and vice versa. Maybe this could change with the new theories, but for now it's the case. The operational efficiency of physics, its experimental successes, have become so impressive with the detection of the Higgs boson, for example, or the gravitational waves, that we are entitled to think that this distinction it makes between time and becoming is also a philosophical discovery. It affects philosophy itself and should ultimately affect the meaning of the expression we use to talk about our experience of time. I know that this distinction in physics between time and becoming might appear quite abstract, but it can be illustrated more concretely thanks to the work of a painter who is Roman Opalka, who died a few years ago. And as you probably know, Opalka, between 1964 and his death in 2011, he painted the sequence of all numbers day after day for 46 years. Whenever a canvas was completely filled with numbers, he took a black and white photograph of himself. The succession of numbers he painted is a material expression of the course of time, which does not change as it passes. Each number written has obviously never been written before, just like every present moment is new, but it is always achieved in the same way, using the same simple protocol by adding 1 to the previous number. As for the photograph that Roman Opalka took of himself in exactly the same conditions, they express the slow sequence of changes affecting his body, that is, the irreversibility of his own aging. This shows two completely different realities. On the one hand, the course of time represented by the succession of numbers, and on the other, the becoming, illustrated by the sequence of portraits of the same human being undergoing the processes of change. This dual representation, the first one that counts, the second that recounts, is all that we need to demonstrate that both sorts of irreversibility, which we constantly see combining in everyday life, can actually be separated out, as physics suggests, or in fact demands. Is it the end of the story? No, of course, for at least one reason. Within the line of time, the present appears unique to us, radically different from all the other instants, because it is the one in which we are present. The only thing that distinguishes the present from the other moment is that it hosts our presence. However, on the line representing physical time, it is a perfectly ordinary moment. Nothing seems to distinguish the present from the other moment that come before it, or that those that come after it, apart from the fact that we are present in it. One question therefore arises. What makes the present moment, in physical terms so ordinary, become so singular for us? At the end of his life, Einstein said that he was very troubled by this question, the question of the status of the present. His theory, the special relativity, stipulates that what is present for us at a particular moment no longer exists or does not yet exist for an observer traveling in relation to us. It therefore becomes impossible to define a present moment in which all the phenomena occurring at the same moment in the whole universe would appear. It then struggles to justify the present of the present, as we could say. In his intellectual autobiography, the Rudolf Carnap, who, as has been said this afternoon, has been a member of the Vienna Circle, recounted an anecdote which is enlightening. He wrote, once Einstein said that the problem of the now, worried him seriously. He explained that the experience of the now means something special for man, something essentially different from the past and the future, but that this important difference does not and cannot occur within physics. That this experience cannot be grasped by science seemed to him a matter of painful but inevitable resignation. I remarked that all that occurs objectively can be described in science. On the one hand, the top-down sequence of events is described in physics. On the other hand, the peculiarities of man's experiences with respect to time, including his different attitude towards past, present, and future, can be described and in principle explained in psychology. But Einstein thought that there is something essential about the now, which is just outside of the realm of science. So the last question is the following. Can physics alone get to the bottom of this problem? Will it in future resolve the question of the status of the present by itself? If so, this means that something is still missing in physics, that it is therefore incomplete because it is not yet able to describe in purely physical terms the entirety of our experience of time. But if the course of time is dependent on our subjectivity, then that is a property that lies outside the realm of physics. Which other disciplines should be looked to explore this further? The cognitive sciences, the neurosciences, philosophy, or something else? I thank you for your attention.
Thank you. I'll take questions. The first one is the guy over there. Okay. Fine.
I just wanted to disagree with you about one of your criticisms of Newton. I don't think that he made a mistake. We had the passage where he describes absolute time put up earlier, and in it he says very clearly that it is something that flows. So for Newton, the simple act of making it a variable in his equations, or even maybe writing a line, although I don't know if Newton did that, Kant talked about it, but that act did not spatialize time for him at all. And I feel that it's more fair to say that Newton had very much the common sense understanding of time that Yuval described in his talk. And just one more small comment. I don't think that Newton could possibly have used a different word when he put the variable t into his equations, because what he was doing was not coming up with a variable and making an interesting equation and then deciding how to name it. He was doing dynamics, which means he was trying to use equations to express how things develop over time. And so he would have just confused his readers if he used some other word for.
Yes, I do agree with you, but the fact that t is a parameter which is homogeneous. I mean, t doesn't change, the status of t doesn't change when time passes. That only means that the equations of physics do not change when time passes. They are the same at all the instants of time, which will lead to the laws of conservation of energy with Émile Noether. But what I wonder is why he said it was time, because what was said about time at that time did not look like the properties of this parameter. Maybe the fact that time doesn't reflect the phenomena that occur into time and so on. It's a very strange idea. And the general problem is, how can you say in a new formalism that this variable is t, for example, if you have not previously defined what you call t? I had this discussion with Carlo Rovelli, because Carlo Rovelli said that the new formalism do not contain any idea of time, but it does not precise what he called time. So what the a priori characteristic that time should have to be recognized in a mathematical structure? That is the question. And this question is asked to Newton and to other physicists of today.
We have a follow-up, no?
Yeah, just follow-up.
Okay,
the follow-up is this. The first point is that Newton needed this notion of absolute time to ground the first law of motion. Because, of course, inertial motion is characterized by the fact that the body travels equal spaces in equal time. And the second thing, as far as I remember, is that Newton needed this notion of a flowing time because, of course, he called his differential calculus fluxions. So he really thought that a figure could just be traced by its motion. So it's not an accident that he calls the fact that time flows a flowing object or whatever.
Okay, thank you for the argument. No.
So, I would like to go back to your presentation as a whole and thank you for a very interesting and well put broad subject on what is time. I have a twofold question. The first one concerns Meliasu's and speculative realism movement as a whole, which I find very interesting, especially nowadays, and the theme of ancestrality. So the first question is, how much do you think is important ancestrality as a subject, and how do you think that physics and other sciences, but especially physics, can respond to it? And the second part of the question is, because exactly Meliasu was rather, well, ignorant of physics and other subjects, but still made a good case. But as you said, I also believe that it's very important, especially for the element of time, to have a more broader knowledge, and different disciplines should go in, as neuroscience, psychology, and so on. But myself, coming from creative arts field, I also believe, and I was very happy that you saw the last example, that art can also help with the perception of time, especially. So these are the points.
It's a very rich question. For the first part, the book of Quentin Meliasu is Après la finitude. That's the French title. And when I read this book, I was really convinced by the arguments. But a few weeks in January of this year, a new book came out written by Michel Bitbol, whose title is Maintenant la finitude. And he tries to argue with Quentin Meliasu, explaining that his main argument is not right. I mean, you can retro-project in the past what we know thanks to physics. But physics is not a true description of reality. So you can retro-project our knowledge, but not the truth. Okay? And for the second part of your question, I mean, the relation between physics and art and so on.
Whether you believe that other disciplines outside the field of science can really be of help to the understanding of time, and especially the perception of time?
I think that we much more understand what we call the arrow of time than what we call the course of time. We do not feel the course of time. We just feel the changing occurring in our life or in our environment. And that's why there was this confusion between time and becoming.
Exactly, and that's where I'm saying that maybe other art, as you suggested as well, other sciences and other disciplines as art can help us in the course of time, not in the hour of time itself. The understanding of it, the perception of it.
I have to think about it.
Thank you very much. I would like to take issue a little bit with this. Sorry, what am I doing?
Your voice has a resonance.
Really? Okay. Maybe I should speak without microphone.
Speak loud.
Okay. So this Kant-Smollett idea that we spatialize time, we represent it as a space-time diagram because we represent it as a property extended in space. That's a little bit unfair. That's not obviously true to me. First of all, a space-time diagram is an extended object in 4 dimensions because it usually persists over some certain period of time. Now you could say that the added sort of temporal extension of it doesn't add to its representational capacity, and therefore, you know, that's sort of a moot aspect of it, and that may be so. But when you think about it, what you're doing on a finite piece of paper is you're representing the else-when, the non-present moments in time, presently on that thing, just as you represent the elsewhere places in space here. So it's not obvious to me that there's really that much of an asymmetry going on.
But I think the good answer depends on the way you interpret special relativity or general relativity. I mean, if you believe that there is a block universe, the answer that you give to this question is not the same as if you consider that, for example, the future at the moment where I talk doesn't exist at all. So.
Next one is Barbara.
Do I create resonances? If not, I can stand up and speak loudly. People can hear me there. But Newton, first of all, let me say something about Ptolemy. Ptolemy actually, what Newton says about time when he goes into more details is very heavily influenced by Ptolemy and what came later. So Ptolemy decided that the rotation of the heavens was the measure of time. So he assumed that the rotation angle of the Earth in modern terms is uniform, so that time is homogeneous as measured by the rotation of the Earth. And he already knew perfectly well that sidereal time did not agree with solar time when the sun is due south, because the sun does not move uniformly around the ecliptic, and it also moves from north to south. So that's called the equation of time, and it fluctuates about 17 minutes either side of the mean. So Ptolemy was the person who, in his Almagest, in about 150 of the modern age, fixed the measure of time. Then the next really significant thing is Kepler's discovery of his second law, where he discovered that if you take the rotation of the Earth as the true measure of time, then the area swept out by the planet as it goes around in its orbit is actually a good measure of marches in step. They march. They don't have the same rate, but the ratios of the rates remain constant. So that's the next good clock that is discovered compared with the Earth. And then soon after that, in Newton's time, the first astronomer royal, John Flamsteed, established that pendula keep very good time with sidereal time. So that's 3 clocks. And if you read further on in the Newton's definition of absolute time, you will find that he refers to the equation of time and to Flamsteed's experiments. Now, next, the thing which is very interesting, if you look at Newton's proof in his Principia, where he proves that from the inverse square law, you will get an elliptical motion. It's fascinating. What does he use as the measure of time? He uses the area swept out by the planet as it goes round. So in one diagram, he has the measure of time, which is the area swept out, and he can measure also the acceleration by how much the elliptical motion deviates from the straight line. It's quite fascinating. So my feeling is that Newton actually had a very realistic notion of time, and he was saying that he can talk about time flowing uniformly because there are different motions, a very different character that actually go in step together. So I think that's a different way of thinking about it. And the final comment about Mach is he said Newton's laws were not verified with respect to absolute space and time. Spatially, they were verified relative to the distant fixed stars, and with respect to time by the rotation of the Earth. And de facto, that was what Newton was doing too.
I thank you very much, because these are explanations that I was missing.
Thank you. Next one is... No, she. Sorry. We have to respect the...
Yes, but you see better than me because you're there. You see better than me.
No echo. So you raised at the outset of your talk several questions which could be answered maybe simply, such as was time passing before there were humans in the universe during those 13 billion years and so on. And you mentioned the fact that, I don't remember the example, Newton was born after Galileo or something like that, as a statement whose truth value doesn't change. So I want to take these two instances just to highlight the significance of ordinary language, because the second statement is not correct. I mean, Newton, the statement that Newton was born after Galileo is correct after both of them were born. Grammatically, people brush aside this grammatical. Don't make an echo. But some people take grammar of ordinary language very seriously, and I mention this because I think quite a few of the questions that you raised at the beginning of your talk can actually be addressed in a fairly satisfactory manner by focusing on our words, which was something very popular 70, 80 years ago, but is really not popular today. Maybe we should return to that.
Do you think of, for example, the article of McTaggart and the article of McTaggart about the existing? No.
I'm talking about what was known as ordinary language school of philosophy, mostly in England. McTaggart, I don't think, was part of it, but which I think did come up with very powerful tools that can address. Now, that's not my question yet. You stopped your quotation from Carnot, but it goes on. So let me just read some sentences from there. So it goes on where you stopped. Carnot says, we both agreed, me and Einstein, we both agreed that this was not a question of a defect for which science could be blamed, as Bergson thought. And then Carnot goes on, I don't know if he speaks for himself or for both of them. Since science in principle can say all that can be said, there is no unanswerable question left. That's a continuation of a passage. And you mentioned Lee Smolin thinking that we need to unfreeze time. And you asked yourself, what would the equations of physics tell us if we could speak? So my question is, since all these comments that you made seem to point, or at least that's my impression, that you kind of agree with Carnot that physics, whatever can be answered in a valuable way will be answered by physics, or let's take the comments that were made before seriously, by science, various fields in science. And my question is, do you nevertheless think that there should be given some weight to ordinary language, ordinary experience? Maybe that's where the key, for the insights that we're looking for in science, that's where it actually lies.
I don't know how to answer, because as you know, the laws of physics contradict the phenomena that they explain. I mean that to explain the phenomena which are irreversible, we use equations which are reversible. This is the paradox of reversibility appearing in the 19th century. And so we have to explain why the universe is less symmetrical than the equation that describe it. Okay? And that means that when you have to explain becoming or changing, you have to interpret the equation, because changing contradicts the equation. And we have several explanations for the irreversibility of phenomena, the second law of time, the increase of entropy, the measurement in quantum physics, the expansion of the universe, and so on. And so we interpret the equation to explain why we assist to irreversible phenomena when the equation says that that kind of phenomena cannot occur. Okay? And the question is it the end of the story, or will it happen that we will have to introduce in the fundamental equation some kind of irreversibility? For example, making the parameter t depending on itself, t will be a function of t, or writing equations which are not reversible, like the heat equation and so on. That was a tentative made by Prigogine, but he never presented a formal theory where the fundamental law could be irreversible. So we are waiting.
Okay, last question.
Yeah, I think it's a vain search for a theory-independent theory of time because of the lack of unity of physical theories, not to mention with other sciences. So the definition of time within the theory of time is as unsuitable as a definition of number within number theory is provably indefinable, the notion of number within number theory. And that's the situation we are, and we should look for operatorial notions of time, namely depending on the context where it operates. So in classical mechanics, we have Hamiltonian, where time is given a clear role as a parameter, and it describes the dynamics as a parameter. This goes to Schrödinger and the beauty of Schrödinger equation, where there is a beautiful duality that explains both energy and time, because energy is an operator and time is a parameter. Then you have Pauli theorem that tells you, as energy is a bounded operator in Hilbert space, time has to be a parameter, and we do understand in this context the precise operatorial role of time, which is clarifying in this issue. The two areas are not unified. There is a beautiful reason to unification that should be mentioned in this context, a beautiful result, purely mathematical result by Alan Kohn. Namely, he showed that the irreversibility proper to quantum measurement, so you first measure position, then in momentum, you get different results if you reverse the order in time. And this forces the mathematical description by a non-commutative for Neumann algebra, and that the same algebra can be interpreted as the thermodynamic flow, the statistical flow. This is a purely mathematical result whose physical meaning is totally obscure. There is no physical meaning. But also Newton equations, except to Einstein, said gravitation without any physical meaning. I mean, we needed Einstein to give a physical meaning to Newton's equation. A priori, it was known. So it happens that sometimes you have, in all these contests, the role of time is what defines it, and we cannot say no more, no less than that. Unification to bring things together and give at least a unified notion of time is a very hard task. And this may be searched for. No way to give, and I'm very surprised to see people, colleagues working in theory of relativity, who of course don't believe in an absolute time, at the same time, sorry for the puzzle, to propose to search for an absolute theory of time. I mean, no, there is no way. I mean, we can correlate, set bridges, dualities, and suddenly in that steps in the theory where time has the most robust role, where time is constitutive, that it is theory of evolution biology. In all your approaches, to use a terminology from Kant, time has a regulating role in the construction of objectivity, while in biology, time as a constitutive role is intrinsic to the understanding. That's a very different status, and we have to compare it to it. So we have to accept these scattered views of time and set a dialogue, but in no way search for a theory-independent theory of time.
Okay. Any more questions? Okay. Thank you very much.
Well, Our next speaker is also our last speaker, at least for today, is Jean-Claude de Moncel, and he will talk about, and the title of his talk is Between the Time of Physics and the Time of Philosophy, the Time of Tense Logic, So Sein, Dasein, Zeitsein. Jean-Claude de Moncel teaches philosophy of mathematics at the University of Caen. He also particularly interested in the works of the founding father of temporal logic, Prior, and he's author of several books about Whitehead, Deleuze, and the philosophy of mathematics. So I just wanted to stress that Jean-Claude will speak in French, but no worry, at least for those who don't speak French, because he will help us to understand more fully by using the blackboard. The stage is yours.
Merci beaucoup. Je remercie d'abord, peut-être pourrais-je utiliser le micro, je ne sais pas. Oui, le micro, voilà. Ça marche? Ok, ça marche. Je remercie donc les organisateurs pour cette invitation que je suis très heureux d'accepter. Donc mon propos va être en trois parties principales qui seront d'abord une généalogie de la tense logic de Prior. Deuxièmement, je ferai une petite incursion dans la physique. Et enfin, en dernier lieu, je dessinerai au tableau le Zeitsein, qui occupera donc une partie droite du tableau. Mais je vais donc commencer mon propos par une sorte d'introduction à la tense logic, en m'excusant du caractère élémentaire de cette introduction, mais en même temps, ça racontera une histoire que je n'ai pas trouvé racontée de la même manière ailleurs, donc ce sera peut-être mon excuse. Et cette généalogie de la tense logic va elle-même passer par trois phases principales. Il y aura d'abord ce qu'on peut appeler la fondation leibnizienne, puis il va y avoir la mathématisation de la logique modale, parce que la tense logic fait partie de l'ensemble, c'est une des branches de la logique modale, pardon. Et il va y avoir une mathématisation de la logique modale, mathématisation au sens précisé par Goldblatt, à ne pas confondre avec la simple axiomatisation de la logique modale qui, elle, est acquise depuis 1932, alors que dans les systèmes de Lewis, alors que la mathématisation dont je vais parler, on va la trouver sous sa forme canonique chez Kripke. Bon, mathématisation. Et puis enfin, troisièmement, il y aura l'émergence de la tense logic de Prior. Mais d'abord, la fondation leibnizienne. La fondation leibnizienne qui va intervenir à partir de ce qu'on appelle couramment le carré logique ou le carré d'Aristote, mais qu'on peut appeler aussi le carré d'Apulée. Et le carré d'Apulée, il va prendre la forme des quatre postes A, E, I, O, et que je vais simplement rappeler, dans l'enseignement scolastique de la logique, c'est une façon simplement d'introduire la quantité logique au sens d'Aristote, et je vais le rappeler plutôt ici avec les symbolismes d'aujourd'hui, c'est-à-dire avec les quantificateurs, qui vont se distribuer comme ça, et puis on va avoir comment dirais-je, en diagonale leur négation, et on trouvera donc par conséquent le fait que, par exemple, ce qui est vrai de tout, si c'est vrai de tout, alors c'est vrai a fortiori de quelque chose. Bon, ça et Leibniz va faire une comparaison capitale avec il les invente plus précisément avec deux autres illustrations de ce même carré d'Apulé, d'abord dans le domaine précisément des modalités. Donc nous allons avoir notre carré où vont se placer les modalités élémentaires, puisque, vous le savez, la logique modale, c'est l'étude essentiellement des deux concepts de nécessité et de possibilité. On va les introduire avec le symbolisme usuel. Nécessairement P, et il est possible que P, avec donc la relation de subalternation, comme dans toutes les illustrations du carré apuléen. Et puis les autres modalités se définiront évidemment par négation, diagonale. Il va y avoir l'impossibilité et puis la non-nécessité que Leibniz appelle aussi la contingence. Et puis l'autre découverte leibnizienne, c'est que nous avons encore il y en a d'autres, mais au moins une illustration dans le domaine du droit. Où nous allons avoir, par exemple, le fait que si c'est obligatoire, par exemple, s'il est obligatoire de payer ses impôts, alors, a fortiori, il est permis de payer ses impôts. Et puis, toujours par négation, on obtiendra les autres modalités, l'interdit, et si c'est pas obligatoire, on pourra dire par exemple que c'est facultatif, etc. Et de cette comparaison entre les interprétations possibles du carré apuléen, Leibniz va tirer deux conséquences capitales qui vont constituer ce que j'ai appelé la fondation de la logique modale. D'abord, en comparant la vieille histoire médiévale des quantités logiques avec ce qui se passe pour la nécessité, Leibniz va faire ce qui va être sa contribution la plus connue, c'est-à-dire son interprétation de la nécessité. Nécessairement P, qu'est-ce que ça veut dire? Ça veut dire que quel que soit le monde possible que je considère, alors il est vrai, vous voyez que je me sers du symbole d'assertion de Frege transformé ici en adverbe de vérité, il est vrai que, alors il est vrai en W que P. C'est l'idée leibnizienne que la nécessité, c'est la vérité dans tous les mondes possibles. Et cette définition, ou cette analyse de la nécessité qui va se révéler décisive ici, je crois qu'il est bon de lui donner un nom, c'est ce qu'on pourrait appeler le pont de Leibniz, parce qu'on va voir qu'il va arriver d'autres choses à ce pont. Bon. Puis Leibniz va également tirer une conséquence qui est implicite dans le fait qu'il découvre cette série d'interprétations, mais une conséquence que je vais expliciter dans le symbolisme d'aujourd'hui. Vous voyez que par là même, en raison de ce parallélisme, on peut parler de quelque chose qui serait une modalité généralisée. Et ça se traduit dans le symbolisme actuel par le fait que la nécessité généralisée va nous donner la modalité box, et puis la possibilité généralisée va nous donner le symbole diamond. Bon, donc le diamond est dans la box. Voilà la deuxième découverte fondamentale de Leibniz, dont c'est cette notion de modalité généralisée dont nous allons voir maintenant la suite. Le deuxième épisode, donc, c'est la mathématisation de la logique modale par Kripke, mathématisation qui est présentée usuellement par ce qu'on appelle un modèle de Kripke. Et ce modèle de Kripke, on va voir qu'il va être bon de l'écrire sous deux formes. Sous sa forme la plus usuelle, donc un modèle de Kripke, c'est un couple dont le premier terme est lui-même un couple. Le couple d'un ensemble W de mondes, qui est un ensemble de mondes, on l'appelle comme ça parce que c'est un ensemble de mondes possibles, et puis d'une certaine relation P qui, sous sa forme originelle chez Kripke, est la relation de possibilité relative. C'est l'idée qu'un monde possible est possible relativement à un autre. Voilà. Ou que par rapport à un monde possible, il y a d'autres mondes qui sont possibles relativement à lui. Bon. Et alors ça, c'est la forme. Le deuxième terme du couple, donc c'est une relation dite d'évaluation, une fonction dite d'évaluation, fonction qui va nous dire dans quel sous-ensemble de W une certaine proposition d'un certain langage va être vraie. Voilà. Il sera bon, je crois, de faire une analyse de cette définition bien connue, une définition qui est précisée par des spécialistes de la question actuelle qui est Blackburn, mais que je vais formuler dans un langage plus familier aux philosophes, qui est le vocabulaire de Husserl. Nous pouvons dire que dans un modèle de Kripke, le premier terme, les mondes possibles et la relation de possibilité relative, le premier terme, ça nous donne l'ontologie du modèle de Kripke. Tandis que, en termes husserliens, qui sont d'origine aristotélicienne, la fonction de valuation, c'est ce qui va nous donner l'apophantique du modèle, c'est-à-dire ce qui va décider de la vérité dans ce modèle. Bon. Mais ce modèle de Kripke, une petite précision sur sa forme originaire peut-être, c'est que j'ai donné la forme originelle, c'est-à-dire la possibilité relative, mais plus couramment, au lieu de dire qu'un monde possible un monde est relativement possible, est possible relativement à un autre, on dit aussi que tel monde peut accéder à tel monde. C'était le vocabulaire de Geach. Et vous voyez que chacune de ces relations est la converse de l'autre. Si le monde W accède à W', alors ça veut dire que W' est possible relativement à W. Bon. J'écris autrement ce fameux modèle de Kripke pour une raison qu'on va voir. Aujourd'hui, pour des raisons importantes, il serait plus approprié d'écrire le modèle de Kripke de la façon suivante. Pourquoi ? Parce que dans l'usage qui est devenu celui de la logique modale, surtout dans l'école d'Amsterdam, eh bien, le premier terme, c'est un ensemble quelconque. Il suffit que ce soit un ensemble non vide. Voilà. Et puis, R, de la même façon, c'est une relation binaire quelconque. Peu importe. On pourra toujours construire une logique modale à partir de ça. Et alors V, c'est toujours la fonction de valuation. Si on peut encore parler de vérité, ou alors on peut parler de 0 ou de 1. Bon. Maintenant, que devient, et pourquoi y a-t-il mathématisation ici, et que devient le pont de Leibniz dans cette mathématisation? Que devient la définition de la nécessité que nous donnait Leibniz? Alors, ici, ça va nous donner quelque chose comme ce qui suit. il est vrai dans un monde W que nécessairement P, si et seulement si, quel que soit... pardon. Qu'est-ce que soit le monde W', si W est possible relativement à W, alors il est vrai en W' que P. Donc l'élément nouveau ici, c'est que la relation dite d'accessibilité ou de paramétrisation va venir donc intervenir en supplément c'est une sorte de passerelle supplémentaire qui s'ajoute au pont de Leibniz. Et alors pourquoi est-ce que c'est une mathématisation? On va le voir en examinant un problème, en examinant cette fois-ci, on vient de voir ce qui se passe pour le pont de Leibniz, on va voir ce qui se passe pour la deuxième idée clé de Leibniz, c'est-à-dire l'idée d'un parallélisme entre différentes logiques modales correspondant aux différents aspects, aux différentes parties de la philosophie. Par exemple, dans ce que Kripke appelle les modalités métaphysiques, on va avoir des lois qui étaient déjà connues des médiévaux. Par exemple, si nécessairement P, alors a fortiori on a P. Et si on a P, alors a fortiori il est possible que P. Bon, comparons avec ce qui va se passer du côté de la logique déontique avec des notions comme obligation, permission, etc. Bon. S'il est obligatoire de payer ses impôts, ça n'implique pas cette fois-ci qu'on paye ses impôts. Et de la même façon, par exemple, si quelqu'un fait de l'excès de vitesse, ça n'implique pas qu'il a le droit de faire de l'excès de vitesse. Par conséquent, on constate que la similarité structurelle, comme dirait Russell, entre les différentes illustrations du carré d'Apulé dissimule en fait des différences. Et c'est là qu'intervient la pertinence de la relation dite de paramétrisation, parce que elle va nous dire ce qui est présent du côté des modalités métaphysiques et ce qui est absent du côté de la modalité déontique. Ça va se jouer vous le voyez sans doute, sur le fait que la relation P doit être une relation réflexive, n'est-ce pas? Si nous avons, puisque ça peut être une relation quelconque, si nous avons W égale W est possible relativement à W, alors le fait qu'il est vrai dans W qu'on a nécessairement P nous permettra effectivement d'inférer qu'il est vrai dans W que P. Donc si on impose à la modalité quelconque dont on parlait tout à l'heure, si on impose à la modalité d'être réflexive, on obtiendra halfway house de paix entre les deux modalités, et on ne l'obtiendra pas si on ôte cette clause et si elle joue le rôle de condition nécessaire. Voilà, ça c'est la mathématisation au sens de Kripke. Pourquoi mathématisation? C'est Goldblatt qui a eu raison de dire que c'est une mathématisation. Pourquoi mathématisation? Parce que ce sont les propriétés formelles de la relation, les propriétés mathématiques comme la réflexivité, la transitivité, etc., les propriétés mathématiques de la relation de paramétrisation, ce sont ces propriétés mathématiques qui contrôlent le fait que telle ou telle loi va être vraie dans tel ou tel système axiomatique et ne sera pas vraie dans tel autre système. Bon, donc ça c'est le pas décisif accompli par la logique modale. Et donc ça va nous mener au troisième épisode, qui est l'épisode de Prior. C'est l'épisode de Prior, c'est-à-dire l'émergence de la tense logique. Et pour qu'il y ait la tense logique, c'est plus précisément la conception de la logique du temps par Prior. On peut dire que Prior est le fondateur de la logique du temps. On va voir ses ancêtres tout à l'heure. Il est le fondateur de la logique du temps, mais aussi plus précisément de la tense logique. On va voir la différence entre les deux. Alors, qu'est-ce que va faire Prior? Eh bien, il va d'abord édifier une logique du temps. Et cette logique du temps, elle va mettre en jeu l'ensemble de l'histoire de la discipline, puisque nous allons voir la constitution de la logique du temps par Prior, c'est la rencontre de saint Thomas d'Aquin et de Diodore Chronos. Voilà. Quelle forme ça va prendre? Il va s'agir de... Comment dirais-je, on peut se concentrer évidemment dans le carré apuléen, vous l'avez compris, sur ce que j'appellerais la colonne AI, c'est-à-dire celle qui est illustrée par exemple par la nécessité et la possibilité. Et par conséquent, il va s'agir de construire la colonne qui va permettre de parler d'une logique du temps. Avec ces deux extrémités AI, et puisque c'est une colonne, donc je parlerai de la base de la colonne et puis du chapiteau de la colonne. Alors à la base, qu'est-ce qu'on va trouver? Ça va être la contribution de Thomas d'Aquin. Pourquoi? Parce que Prior va trouver, dans un commentaire d'Aristote par Thomas d'Aquin, il va trouver ni plus ni moins qu'une définition du passé et du futur. Thomas d'Aquin nous dit qu'est-ce que si quelque chose est présent, si quelque chose est passé, ça veut dire que sa présence est passée. Et qu'est-ce qu'on veut dire quand on dit que quelque chose est futur? On veut dire que sa présence est future. Et ça va avoir au moins un avantage quand il va s'agir pour Prior de construire la logique formelle, parce que ça va lui permettre une économie de symbolisme. Pourquoi? Parce qu'il n'y aura pas besoin de symboles pour le présent, parce qu'on pourra mettre simplement la proposition P, puisque les propositions dont il s'agira en logique du temps, ce sont des propositions comme par exemple « il neige en ce moment à Paris », c'est-à-dire des propositions qui sont quelquefois vraies, quelquefois fausses. Et par conséquent, il suffira d'introduire deux symboles, un symbole pour le passé et un symbole pour le présent. Pas pour le présent, excusez-moi, un symbole pour le futur. Et ça nous donne ce qu'on peut appeler le piédestal de la colonne que va édifier Prior. Mais il faut encore maintenant le chapiteau. Et le chapiteau, ça va être obtenu par le travail que va faire Prior sur les modalités de Diodore, dont la définition des modalités de Diodore nous est parvenue par Boès. Mais c'était des définitions très mystérieuses, personne ne savait quoi en faire. On va en prendre simplement un échantillon. Comment est-ce que Prior définit la nécessité? Il dit est nécessairement vrai ce qui est vrai maintenant et ne sera jamais faux. Voilà la définition de la nécessité par Prior. Mais vous voyez que dans l'édification de la colonne de la logique du temps, c'est en quelque sorte un Janus hémiplégique qui regarde la modalité de Diodore, un Janus hémiplégique qui regarde seulement dans le futur, mais qui n'est pas capable de regarder dans le passé. Alors que va faire Prior? Il va symétriser il va symétriser ça pour obtenir les deux modalités désirées. Parce que vous avez déjà compris, n'est-ce pas, que la différence entre la logique du temps, c'est que sur la différence de la logique du temps par rapport aux autres qu'on vient de voir, c'est que sur chacun des postes du carré apuléen, il y aura non pas une modalité comme d'habitude, mais deux. Donc, Prior va définir les deux modalités en question, c'est-à-dire il y a d'abord celle qui est déjà définie par Diodore Chronos, qu'on peut dire en français, je crois, dorénavant P. Et puis, il va la compléter donc, par ce qui va être la duale du présent, c'est-à-dire auparavant P. Mais il faut se donner un symbolisme aussi, évidemment. Alors, il ne faut pas oublier ici qu'on a au milieu, entre les deux, on a le P du présent. Et puis, alors le symbolisme s'explique par le fait que c'est quelque chose comme has always been the case that, et is going always to be the case that P, etc. Voilà. Donc ça, c'est la façon dont Prior va, d'une certaine façon, inventer la logique du temps d'aujourd'hui en faisant se rencontrer Thomas d'Aquin avec Diodore Chronos. Mais ce n'est qu'une étape dans l'édification dont il s'agit de voir les épisodes principaux ici. Le deuxième épisode chez Prior, ça va être l'équivalent de ce qu'on a observé chez Kripke, c'est-à-dire la mathématisation de la logique modale du temps. Alors, elle peut être datée, je ne sais pas si je vais retrouver la date, c'est pas grave. Donc, ça intervient dans une adresse, un discours de Prior, et le point, c'est qu'est-ce qui va arriver à la modalité de... On va l'illustrer, par exemple, sur la modalité dorénavant. Donc, il s'agira de définir le fait qu'il est vrai pour un certain instant t que dorénavant p, donc on le définira de la façon suivante. Ça va correspondre cette fois-ci à la quantification universelle, évidemment, là encore. Donc, ça voudra dire que quel que soit l'instant u que je considère, si U vient, si T est suivi de U, si après T vient U, alors il sera vrai en U, il sera vrai en U que P. Voilà. Donc ça, c'est ce qu'on peut appeler sur le pont de Leibniz dont nous sommes partis, c'est ce qu'on peut appeler la passerelle de Prior, qui va être historiquement, la première mathématisation de la logique modale, puisqu'il va y avoir toujours le rôle de la relation de paramétrisation, la première mathématisation de la logique modale sous la forme de la mathématisation de la logique du temps. Bon. Plus précisément, on va l'illustrer sur un exemple. Prenons un des exemples de loi de logique du temps le plus simple. Par exemple, s'il est futur que P, alors il est futur que P. Comme vous le voyez, cette loi sera vraie sous une hypothèse, à savoir que le temps soit un ensemble dense, tel qu'entre deux instants, il y ait toujours un instant considéré. Et par conséquent, là encore, c'est l'ontologie, c'est le fait que le temps a telle ou telle propriété mathématique qui va faire que telle loi logique est vraie ou non, est une loi ou non de tel ou tel système. Et par conséquent, là encore, n'est-ce pas, nous avons le contrôle de la logique en tant qu'apophantique par l'ontologie qui lui est associée, c'est-à-dire par les propriétés qui sont accordées à la chose dont on parle ici, le temps. Voilà. Et puis, il nous reste à aborder la dernière étape de la construction de Prior, c'est l'avènement, oui. Ah oui, 5 minutes. Ok. Alors, je suis désolé, je n'aurai pas le temps de vous dessiner le Zeitnote, mais ce sera pour une autre fois. Donc oui, je vais terminer ce qui concerne la logique du temps. C'est pas très grave parce que, comme vous l'aurez constaté, je voulais d'abord, puisqu'il y a ici un éventail des différents aspects du temps, temps logique, temps physique, temps pour philosophes, etc. Je voulais essayer de glisser dedans l'aspect logique du temps. Donc, je terminerai par le dernier point de la création de Prior, c'est-à-dire l'avènement de la Tanzlogique. L'avènement de la Tanzlogique, on va pouvoir illustrer sur sa définition du futur, par exemple. Il est futur que P. Ça voudra dire, donc, il est vrai à tel instant T qu'il est futur que P, si et seulement si. Si et seulement si, il existe donc un temps U tel que il est vrai en U que P. Alors j'ai oublié la relation, j'ai oublié le principal, c'est-à-dire la relation de paramétrisation. Il faut évidemment que T vienne avant U, n'est-ce pas? Donc à glisser dans la définition. Donc pourquoi est-ce que ici c'est la logique la Tanzlogique qui surgit? Parce que pour une double raison. Parce que, heureusement, on a parlé de McTaggart tout à l'heure, n'est-ce pas? Ce qu'il faut remarquer ici, c'est qu'à gauche, nous avons ce que McTaggart appelle la série A, et les relations, comme être avant, être après, etc., eh bien, c'est ce que McTaggart appelle la série B. Et si c'est la série A qui est prédominante, nous sommes dans une conception mobiliste du temps. Si c'est la série B, alors c'est quelque chose comme l'univers bloc, etc. Et par conséquent, ce qui était comment dirais-je, ce qui était chez McTaggart simplement des relations A attribuées aux relations B, eh bien ça va devenir chez Pryor, d'une part, la modalité à définir, et d'autre part, la relation de paramétrisation qui va contrôler cette modalité. C'est-à-dire que Pryor va introduire dans la logique du temps tout le problème métaphysique du rapport entre les deux séries de McTaggart. Et il va inverser complètement la perspective de Leibniz, Carnap et autres, c'est-à-dire qu'on va obtenir ce qu'on appelle le palindrome de Pryor. D'après Pryor, on peut circuler dans les deux sens sur la biconditionnelle, et d'après Pryor, ce n'est pas ce qui est à droite, comme chez Leibniz, qui explique ce qui est à gauche, mais la free logic va apparaître lorsqu'on va demander à ce qui est à gauche d'expliquer ce qui est à droite. Je vous remercie de votre attention.
Thank you.
Merci beaucoup, c'est très intéressant. J'ai appris beaucoup concernant les relations entre les logiques de modalité et du temps, donc c'est très intéressant.
Do you speak loudly?
Le microphone ne m'aide pas, donc je ne sais pas. Quand même, ok, d'accord, merci. Ma question concerne exactement l'exemple que vous avez mentionné, le dernier, avec, il semble, avec les relations de la série A à la gauche et la série B à...
Attribut A à gauche, les attributs A de McTaggart deviennent des modalités de Pryor. Voilà.
Oui, mais il me semble qu'à la droite de biconditionnel, il n'y a pas seulement des relations des attributs B, mais aussi A, parce que c'est important que le moment T est le présent. Et ça, c'est un fait du présent, un fait tense.
Peut-être de surcroît. Mais je me suis contenté d'exposer ici, si j'ose dire, l'orthodoxie de Pryor dans la tense logique à l'état naissant. Il y a peut-être d'autres précisions à lui apporter. De toute façon, il y a un article que je publie très prochainement dans une revue qui m'a été demandée par un ami tunisien. C'est sur... comment dirais-je, parce que vous savez que Quine qui disait que la logique modale était née dans le péché, Quine distinguait en même temps 3 degrés d'engagement dans la logique modale. Et Pryor a, d'une certaine façon, fait une sorte de parodie de cette espèce de parcours de Quine en définissant 3 degrés de plus en plus profonds dans l'engagement, dans la tense logique, à l'intérieur de la logique du temps, précisément. Donc, je ne sais pas, peut-être ce que les précisions dans ce papier classique de Pryor pourront peut-être répondre à votre question. Mais le privilège du présent, ça n'embarrasse pas Pryor, puisque c'est ça qui lui permet de se passer d'un symbole pour le présent, et puisque c'est d'une certaine façon contenu dans les 2 définitions de Thomas d'Aquin, puisque ce que nous dit Thomas d'Aquin, c'est que quand nous disons que quelque chose est passé, c'est sa présence qui est passée, et quand nous disons que quelque chose est futur, c'est son futur, c'est sa présence, pardon, qui est future. Voilà.
Actually, okay, I'm fine. No, go. Okay. So,
in English or French or
je comprends très bien ton anglais, Lee.
So my question relates to, I was very intrigued and interested in the way the parameter was controlling the other side. The tense notion of time is controlled by a time parameter, which is and which made me think of an author, French author that you know well, Albert Lotman. He makes this distinction and forcefully between coordinate time and parameter time as being a structuring duality within physics and mathematics, probably. And then I was reminded, listening to you, that the same Prior that developed tense logic is also the one who wrote this paper called The Notion of the Present, where he very strongly makes a case for the absolute absurdity of assuming that whatever happens out there now, the there now would be relative to the choice of a frame of reference. So a very strong case for the absolute notion of absolute meaning of simultaneity. And I wondered how this strong take on absolute global distant simultaneity interfered with his elaboration of tense logic. Is it a kind of resurgence of coordinate time within his thought, or?
Coordinate time, I don't know. Perhaps there is a possibility to save absolute time in the Newtonian sense, which is relatively unknown, but which is in Russell. Because you know that Russell has successive philosophies, and sometimes some of the stage of Russell are forbidden. And Russell was a defender of absolute time in certain period, and with the following answer to the objection of well-known objection of Leibniz, Russell says the time is as a continuum of colors, and the only possibility to refer to a color is to have an index in the Persian's meaning, to have an index to point on this color, because each color is indefinable. We must have a knowledge by acquaintance of this color. And Russell says the Leibnizian objection on absolute time, which is, as you know, founded on the principle of identity of indiscernibles, this objection on peut y répondre, excusez-moi. L'objection peut être surmontée, because if the continuum of time is as a continuum of colors, each instant is distinguishable from all the others. So we may have a Russellian theory of and if your question in the term of coordinates, each color offers a coordinate on this continuum of time. Russell adds that we have no knowledge of this aspect of time, but it suffices, it is objective to respond to the Leibnizian objection.
Merci pour votre exposé. C'est pas une question, mais je voudrais comprendre mieux.
Microphone.
Parfait. Ce n'est pas une question. Je voudrais comprendre mieux ce que vous avez dit, et à propos surtout de la question du Diodore et de la construction d'une logique du temps à partir d'un argument qui dans la traduction a été utilisé toujours pour nier la réalité du temps. Oui. Alors, à mon avis, il s'agit de quelque chose de vraiment particulier. Alors, je voudrais savoir quelque chose en plus à propos de ce sujet.
Oui, disons que Prior accomplish a double performance. Prior accomplit une double performance. Il fonde d'abord la logique du temps en général, avec entre autres cet emprunt à Diodore Chronos, et de surcroît, il fonde ensuite la tense logique. C'est la tense logique qui exprime la position philosophique de Prior. Mais la logique du temps, elle est fondée pour tout le monde. On peut développer une logique du temps qui serait peut-être compatible avec un univers bloc. D'ailleurs, Prior lui-même, dans Time and Modality, s'est préoccupé du rapport avec la théorie de la relativité et a proposé une axiomatisation qui permet de faire avec la théorie de la relativité. Ce qu'on trouve d'ailleurs aussi chez des disciples plus récents de Prior, comme c'est un auteur italien, mais dont le nom m'échappe, dans le recueil dont je vous avais parlé, n'est-ce pas, puisque en France, le temps est au sujet d'agrégation, on a tous les livres en anglais qui se traduisent sur la question. Donc, je ne sais pas si je réponds à la question, mais par exemple, Prior, Hintika lui-même dit l'argument de Diodore, qui est autre chose que sa définition des modalités, mais le fameux argument dominateur est vraiment un défi pour les logiciens. Mais Prior en a fait une axiomatisation, et une axiomatisation qui fonctionne. Voilà. Mais ce n'est pas notre sujet d'aujourd'hui. Mais c'est vrai que c'est d'une certaine façon une résurrection de cette école de Mégare il y avait d'abord le livre de Benson Mates qui est beaucoup intervenu dans la pensée de Prior, et puis ensuite son article Diodorian Modalities, qui était en quelque sorte le socle de ce qu'il allait faire ensuite.
Okay. Any more questions? Okay, thank you very much. I don't know whether Alessandra, do you want to say something more about for dinner, or we want to try to organize?
Okay. We meet at 8:30 at Fontana Luminosa. Okay, and tomorrow morning at 9 o'clock we are at the Department of Scienze Umane, very close, Viale Nizza 14. You've got all the informations. 8:30 Fontana Luminosa.